So, comment type, question types. Short, very short answer, true, false, with explanation. Explanation is required. I look for an explanation to capture your reasoning. Fill in the blank. Give a few items. So a few points along that are asked for. And there's a lot of those. Longer questions. Yeah, there are a few. There's at least one or two longer questions. Okay. Those longer questions are of a sort that will ask you to undertake some task. And examples of the sort of things that might be asked on a question like that might include, for example, that I might ask you to do a CPM schedule, or I might ask you to do an estimate of some sort, or I might ask you to do a causal diagram, or I might ask you to undertake a Gantt chart that shows some items or something along those lines. So sort of operationally undertaking some task. Okay. So those are most of the items on the exam, the types of items. Let's talk about topics. And for some reason, I'm having some issues with viewing this full screen. It says it's full screen, but it seems to suggest otherwise. So let me throw up that for a second. Dream of Centuries. Okay. Notable topics. This is a pretty good selection of the topics on the exams. I'm not sure there's any major area that is not on this slide. I think there's not. Okay, I think I went through systematically the material that I presented, and these are the sorts of things that I might ask about. Things related to risk management, risk exposure, different ways we buffer ourselves from risk, risk as opportunity as well as risk as threat. Why do I say risk is an opportunity ever? Risk is not always something you want to avoid. Risk is sometimes something you embrace. Why?
Because it can give you high returns.
It gives you high returns. Things that are high risk are hard for a lot of people. And if you can manage that risk more effectively, if you can respond to it, buffer yourself from it, handle it in a mature, competent fashion, you may have a leg up on reaping those high returns in a way that other people don't. Yeah.
Will you be posting these?
Yeah, they're already posted.
Okay.
Or, yes, I think this exact version of them is posted, okay? I posted it last night. And I actually did two versions of it, but this, I'm pretty sure this is the final one. I'll repost them later, but I think it's this exact copy, okay? So risk management, if you listen to what I say, stream of consciousness in terms of these things, you often get a pretty good clue about what I might ask about them, because those are the things in the top of my head. What else about risk? There's ways that we assess risk. One way is by asking about the probability something would happen. What's another way? Severity, yeah. So if it happens, how bad is it? We use those same, basically, where else do we see that? Where else do we see those two divisions? Bugs, yeah, defects, classifying defects, priority, severity. That's a good thing to know as well. Quality assurance, big emphasis on different aspects of quality assurance. Inspections and peer reviews. What are 4 different types of peer reviews that might happen on your team, that you might hold in a team? 4 different things you might call peer reviews in one sense or another.
Inspections.
How about on the far other side of formality? Inspections are very formal.
Pair programming.
Pair programming. What's something a little bit maybe more structured than pair programming, or a little bit more sort of explicit and less sort of run of the moment?
Distance.
Sorry?
Desk.
Yeah, pure desk check. So you say, hey, could someone look at this sort of thing? So that's good. How about another one?
Could bug parties count?
Yeah, I'd be generous and say bug parties. I like to be generous to my students. As those 470 marking. Some of those questions I had to be kind of generous. There's a thing called structured walkthroughs, which are kind of like inspections in the sense that they are structured, they are systematic, but what they don't have is something inspections do have. And this gets into different types of ways in which these differ from each other. They differ in a bunch of different ways. Some of them require pre-review, others just the first time you see it is during the meeting or during the engagement. Some have defined roles, others it's kind of a bit ill-defined whose role is what. Structured walkthroughs are like inspections. The roles aren't as well defined. You don't have a pre-meeting. You don't have follow-up meetings to verify whether or not things have been fixed. So you don't have a work package perhaps sent through. And it's somewhat of an informal form peer review. And actually in this class, they don't strictly enforce traditional inspections. I love something that's closer to structured walkthroughs. So those are some types of peer reviews and some of the ways they differ. Whether there's follow-up, whether a formal checklist is captured, these are important. Continuous integration. What is there to test on continuous integration? Well, what are some of the benefits from continuous integration? What are some of the benefits from continuous integration? Suppose that you folks did not push things up from Git. Suppose you only merged your code 2 days before the deadline. Okay, don't tell me you only did. Please. I know you didn't. I know many teams didn't, at least. Because I would see messages, including failed builds. Fail. But what would have happened if you had done that? If you had only merged your codes, you were working on them independently and you merged them 2 days before the due date, what would have happened?
Severe merge conflicts.
Yeah, there'd be severe merge conflicts, there'd be issues that, you didn't do that? No, I thought you were doing it. Or, wait, you mean you did that? I did that also. And then you have conflicts, like you thought you were the one who was responsible, they thought they were the one, you redid it. Or you did something perfectly reasonable, they did something perfectly reasonable, but there are different assumptions, so your modules don't talk to each other. And so you have the Big Bang problem, it sort of blows up. Imagine doing that once every few months, and that's how software used to be. Remember there was a project called Microsoft Omega. I think they couldn't even get through the compilation errors, over the course of a year or something. It was horrible. It was horrible. And so they ended up deep sixing the project. And they created another project called Microsoft Access that some of you may know about. Omega never got off the ground. It was also using an internal programming language called C#. Back in 1989. About 8 years later, they released a language called C#, which built on some ideas, but was otherwise quite different. Continuous integration. What needs to happen before you check things in? What are some things that should really happen on your side? So before you push things in to others in the repository, what should you be doing?
Running unit tests.
Sorry?
Running unit tests.
Running unit tests is very good, yeah. Not just writing the code, not just making sure it compiles, not just what else should you be doing that goes in code files. What else should you be putting in there besides code? Begins with an S. Ends with an S. There's a C in the middle. Second letter is P. Last letter is N, or second to last letter is N. There's a T. Good, okay. Specifications. You're lucky you didn't play hangman with me there. You would have been on boot hell. So yeah, specifications. You should be writing specifications. Any other documentation? You're running unit tests. What else should you be doing before you check in? What else didn't your teams do occasionally and you got in trouble? With a few of them at least. I know, because I talk with people who visit our marketing sessions. What else that sometimes gets overlooked? You pull everyone else's changes, right, that have occurred? Because you don't want to check in yours, you don't want to commit your changes to the repository if they don't work with the recent changes that have been contributed by others. You want to pull others' changes, right? So maybe others put together pull requests and you're pulling their changes so that you're compiling your code against the latest parts of their code, right? Because otherwise you commit yours and the repository might not be consistent. Your code doesn't play with others. The build fails. What else should you be doing? Speak as in one voice. What else should you be doing before you view it as finished, before you commit it? How about do a smoke test? Be good. Do a build from scratch instead of just building only the things that change. Build from scratch. Those are really things that build confidence. No pun intended. And then you might, and sometimes you might peer review it, right? You might have someone look it over sometimes before you commit it. Okay. Continuous integration is a very important process. Now when you commit it, what's going on there on the build? What might be going on besides it compiling your code on the build side? What else might be happening?
Style check.
Style check might happen. Good. What else? Well, if you're dealing with a website thing, what else might happen at a build? If it's a successful build, it might deploy to a server for testing, right? So you can go test it. The testers can test it. At least for maybe not the latest official stable one, but one that can be fraud. You might refresh the database schema because you're pushing a new schema and the database has to be refreshed and repopulated with data and with the new schema. There might be unit tests run beyond the smoke test, a whole regression test suite. Results from that test suite, written out. These are things that might occur in a continuous integration process. Not always. Sometimes the regression test suite is too difficult, too expensive to run, so you can't do that right away. Ladies and gentlemen, continuous integration is a good thing. It was one of the things that allowed commercial software development to be viable at scale for larger teams. If you didn't have that, you wouldn't have the opportunity to have really large-scale code bases. It's managing risks. It's a way of managing risks with processes. Defect estimation. I talked about several ways of estimating the number of defects in your code. They're not terribly difficult. They're based, the most tempting of them, which include seeding defects and having two teams identify sets of defects independently and look at the overlap. Those are based on the same basic idea of fish tagging, right? To estimate the number of things out there. There's also historical, estimation for larger organizations, although that's problematic with changes in technology, personnel, etc. But defect estimation is basically estimating how many defects are there out there. Ladies and gentlemen, there's a large bug pipeline. There's a large pipeline of defects. And actually surprised no one in 394 on the project for a number of years, but simulating sort of the software development process. But you have defects at different stages, and this early one is undiagnosed defects. These are the undiagnosed defects, the defects that are out there but you don't know about them. And then through certain processes, you get defects that are diagnosed, but basically they're basic raw diagnosed defects. What process goes from here to here? What process allows you to identify a failure of the system? When I say diagnose, I have to be careful here. We're identifying failures. Remember the distinction between a failure and versus a what? Fault. Yeah. What is the difference?
Faults lead to a failure?
Yeah, faults lead to a failure. The fault is the underlying issue. It's the etiology. It's the thing that causes the failure to happen. But what do we observe, generally? In testing, what do we observe? Failure. In peer review, what do we observe, generally? Fault. Big difference between peer review and testing. How do we go from an observation of a failure to find the fault? That's called what? Debugging. Right? And debugging, you could argue, historically, debugging has often included fixing it as well. You debug it. You don't just bug. You don't just find the bug. There it is. You pull out the moth. Do you know about that story? Yeah. I think it was Grace Murray Hopper. She found a moth in the. She found it. Yeah. And it was a bug. She found a bug in there. It was a moth. It had gotten zapped. And she coined the term debugging, I think, from that. In any case, failures, locating faults is debugging, right? So this process here, going from undiagnosed things to find diagnosed, often that's through testing, right? That's through some sort of testing. Sometimes you can also do it through peer review. Which of those is more efficient? In terms of time per bug found, which of those per defect found, which of them is more efficient? Peer review. How about in terms of finding a larger fraction of the defects in a code base? Turns out peer review as well. Testing is great. Testing is great. Testing, ladies and gentlemen, is great. But peer review is even more powerful. Okay? Why is it more powerful? Why is peer review more powerful? I'm doing like a breath first walk. Believe me, I'll get back to that. Why is peer review? Why is peer review even more powerful in some ways? And when it can be done? Peer review can be done on what?
Well, it's done earlier, so.
Done earlier. And how does the ladies and gentlemen, if we find a bug early in a development process versus late, like after deployment, how does the cost for fixing that rise? Cost to fix. And this is sort of time, defect. Now, I use defect generally. It could be a misunderstanding with the stakeholder and so on. Found. How does that cost rise? Does it go down? Does it plateau? Does it oscillate? I don't know. What does it do?
It goes up exponentially.
It goes up exponentially, and it does. IBM is, for example, has done some fascinating studies of this, and it's like $1 per defect found, early on in requirements phase versus $10,000 after it's deployed. Think about an embedded system. You've got firmware embedded in a mobile device, or embedded in a roadside system deployed, worldwide, or you've got it in these motes that can get stuck out and deployed on things, and there's firmware placed on there, written into it, and you've got to replace that, update it. You've got to get devices from people in order to fix it. So it goes up exponentially, ladies and gentlemen. So the fact that you could perform peer review early on requirements documents, on design plans, on testing plans, on test cases, on specifications, that really helps make it cheaper to head these things off. Remember, if you're only finding them later, there's more and more stuff that's been built with the error, entangled with the error, like test cases that have to be rewritten because you had to fix a bunch of methods in terms of what they took as arguments, and now you have to rewrite the test cases, or you change the user interface to reflect the underlying change in process based on the fixed requirement, and all these tests have to be rewritten. So the longer you go, the more stuff has to be redone. For those who have taken 394, there's some amazingly interesting sort of dynamics associated with this process of kind of where defects are, where they get caught, where they get missed, and how they flow in a hidden and then discovered way, and who takes them, and how they breed other defects. Defects breed defects, just like cockroaches breed. Okay, ladies and gentlemen, so going from raw defects to sort of verified defects, there's actually a word of art I'll use for this in a second. What's that word of art? Instead of verified, what's it? Sanitized, yeah. Or we'll use the term active bugs, okay? Active bugs sometimes. But the process is sanitization, okay? And then there's a triage process by which this goes to sort of defects to be fixed, okay? So what goes on in the sanitization phase? What are you doing there? Give me some things that never get it over to the active bugs that are in this kind of diagnosed phase. Duplicates, good. How about another thing? Ones that are outdated. The person reported them, but it's been fixed since they reported it, or it was an old version of the system and it's no longer relevant. What's another thing that might not? It's a system trouble incident that they reported, but it's no longer, it's not something that gets sanitized, that makes it through sanitization. It's a misunderstanding, it's so on. I mean, something that might get through as a real thing, though, it's a misunderstanding. It needs to be reflected in an update to the help system or something like that. But sometimes there's just misunderstandings on a person's part as to what the system is supposed to do, or what the meaning of a certain thing is, that you don't even have to change the documentation.
What about when you can't reproduce it?
Yeah, so it's under-documented, it's you don't have confidence that it's a real bug yet, so it's kind of ill-documented, not reproducible, puzzling. It might stay in this phase for a while before it gets sanitized. It wouldn't be closed and resolved, it would just be, unlike a duplicate, which might be closed and resolved, this would be something which would remain there for later resolution. So that's good. Ladies and gentlemen, specifications. Specifications. Motivations for specifications. Why create specifications? Let me put it another way. Why separate interface from implementation? Why have a separate specification of the interface that's different from just the code? And why have specifications that document what the thing is other than that signature? You know, it has this name with this return type, these arguments.
That allows you to update them in the future.
Yeah, so it gives a contract, right? It specifies a contract. Between the person who created it and the person who's going to use it. That's beneficial at multiple times. There's some people in this room that I'm giving this talk to that don't need to hear this, I know. Because they gave very good answers on the 470 exam. So, but pardon me, I'm going to repeat it for those who did not partake of said exam or did not give me the answers back for which I was looking. So specifications provide a contract between the person who created this and the person who's going to use it. And that contract gives great benefits to both sides, both now and in the future. Why does it give benefit to the person who created it now? Why does it help me to have a specification before I write the code? Test-driven development, right? Why is that? Why does that help me if I have a specification before I write the code?
You have to think less when you're writing code.
You have to think less. Yeah, for some reason I thought I heard you. In fact, I was certain I heard you say you have to spank less. Maybe in some teams that's true, but yeah, you have to think. You don't have to. It's more well defined what this code has to do. Why does it also help?
Defines what the code doesn't have to do.
Yeah, it defines what you don't have to worry about. There's a precondition that specifies what I'm counting on, and you don't have to write lots of mechanisms to sort of deal with the case if it's ruled out because of preconditions. Ladies and gentlemen, why does it help in testing?
Test based on the specification.
Yeah, you can test based on the specification. Why else does it help? What else does it make it almost trivially easy to put into your code that are good things? Assertions. You can put in assertions, ensure statements like we see in Scala, right, for postconditions. Assertions that are asserting preconditions or in Java postconditions. Specification makes it very easy to create these things for when we create the object. Over time, if I'm the user, the creator of that object, and the system's evolving over time, why does that specification help me? It increases, okay, yeah, so it makes it easy for someone new to come to the code. I like this. And understand what this code does, what it needs to do. What else does it help with?
Dictates what can be evolved.
Yeah, what can be changed? Ladies and gentlemen, the presence of that contract, the presence of that contract tells me what other people are counting on. What things I can't change, what they're counting on staying the same. And by implication, it adumbrates, it delineates, it highlights, it sort of makes clear what things by implication I can change. Aspects of the implementation I can change. So maybe all it ensures is that, you know, the element returned is the largest one, and that allows me to implement it in any number of data structures. A heap allows it to do it in a collection that's sorted, in a tree, what have you. I know it just has to return the greatest. Versus, it has to return the very first of them if they have the according to some other criteria, if they have tied values in terms of this other or what have you. So specifications let me know what things are guaranteed and what things by implications I can evolve as the creator. Okay, now I'm the user of this thing. Why does that help me up front? So I'm the user of it, I'm an instance of this, and I see the specifications. Why does that help me? Give me 3 reasons.
You know how it works without reading the code?
I don't have to look at the code, which is great, because often I don't have access to the code. Or if I do have access to code, it takes a lot of time for me to see it. Or what? Why else, if it's an open source system, I can see the code, why doesn't that help that much? Because later the code may change, right? Okay, so when I have the specification, I know what I can count on, it's clear what I can count on, and by implication, some things I can't count on. So it tells me I can't pass it a null pointer, okay, that makes it very clear. Or it tells me that I can, and I can pass it a null pointer, in which case the proposed condition is such, and that allows me comfort that I can use it properly. Now, as the system evolves, why does it help me as a user? Well, I know what could change when I'm getting the latest version of that library, what might have changed, what didn't. What's open to change and what's not. That helps a lot, okay? By the way, we should give proper credit to whoever updated this system. It's so much brighter and nicer. I mean the screen, not the professor. The screen, all right? This is just, we don't have to even shut off the front lights probably going forward, but it's really, whoever did this, I appreciate it. Maybe they'll be listening to this on YouTube, by the way. So they deserve great credit. It takes a lot of work to replace these things. Okay, ladies and gentlemen, specifications help testing. Do they also help peer review? Yeah. They also help testing, not just in what you test there, but in the assertions that can be running and helping it. Specifications are good. Now you may have wondered why I was laughing as I was thinking about specifications. Because, ladies and gentlemen, sometimes I feel just such intensely about wanting to communicate these ideas that I feel like repeating it again and again, exhorting specifications. And I was reminded of a infamous scenario where one of the vice presidents, later president of Microsoft, a guy named Steve Ballmer, who I never really cared for that much, he was famous for, you can go watch the video. He was famous for going to one convention of developers, and he had, I think, a 20 or 30-minute presentation, which he engaged in with incredible vigor. It's like he drank 12 cups of coffee, and he was just like jumping around the stage. I mean, you think I'm, dynamic on the stage. He would be jumping on the tables and, doing flips around and so on. And all he was saying, and he was sweat drenched at the end, completely drenched in sweat, and he uttered one word repeatedly during that presentation. And the word was not specifications, it was developers. That's all he said. He said developer, and he exhibited simian characteristics for the entire lecture, uttering the word developers. And if I had to do that for one word, I'd either do it for specifications or abstraction. But you'll never get to see that. Trust me. Okay. Okay, so testing, ladies and gentlemen. We talk quite a bit about testing in this class. This is sort of like a grand tour of my biggest things. A lot of the things that I'm talking about they're just like ripe for testing. Ripe. Ladies and gentlemen, I tell you, ripe for testing. Okay, testing. General principles of testing. There's a lot of things here. Look, testing is a matter of risk management. Testing is subject to resource constraints. Testing is subject, because of that, to opportunity cost. What do we mean by an opportunity cost?
By spending time on one thing, you can't do other things.
By testing one set of things, I often take time away from testing another because I have limited time. Limited time before the ships, limited time before the client needs to see it, limited time, limited effort for the testers. And what that means is I have to be strategic, I have to be prioritized. When you have limited resource opportunity costs, you have to be prioritized. You don't want to just throw testing at one thing only to find it shortchanged another. That, you know, by investing in testing this, you've cut off the opportunity to test those things. And you got to weigh which of them is going to yield the greatest benefit. Another aspect of general principle with testing is the fact that, ladies and gentlemen, when you're testing something, often when you're testing larger systems, this is above the unit test level, you have to go through a certain environment where you do a sort of setup for the system, you run the test, and then you have to often restore the system to its original state. So you wipe away the results of the test from the database, or you restore the database to its original condition, or you put the testing files back in place, or whatever. You have to sort of get it back to its original state. It's a general principle of testing. Different levels of testing, types of testing. Give me 3 or 4 different levels of testing. What's sort of a low level of testing?
Unit testing?
Unit. Next level up? Integration testing. Here you have multiple components coming together. What would you do? I feel bad for the Unity folks here, because they didn't get to taste the full power and, if I may, the glory of testing. But, ladies and gentlemen, when we are doing unit testing, we don't have access, and we don't want to test other things that are connected with this component. So component A in general will use other components, components B, C, and D, say. What do we, and maybe it's used by E, you know, it's called by E with things. What do we do at a unit test level? If we're in a situation like that, what can we do at a unit test level to still test A without dealing with all those other things, without having them around, without, maybe they're not even built yet? What can we do? We can mock. We can do mocking, ladies and gentlemen. And there's variants of this. Fakes, which are kind of simple forms of mocks. Stubs, that was kind of the old term for it, a stub. That was sort of mocking before the object-oriented era, sort of talked about formalizing it. That's at the sort of unit test level. One of the nice things about mocking environments is they can allow you to declare in a specification type of way, in a declarative way, what properties you want this thing to guarantee. And actually, it will, in the mock that it creates for a certain interface, can actually test to make sure these conditions are held true. Preconditions, for example, or certain invariants, etc. So there's unit tests, integration tests, where you're actually having these multiple components actually work together. What's above the level of unit testing? Or sorry, of integration testing? Begins with an S, has a Y after it. System testing. System testing. Ladies and gentlemen, with system testing, you often have a test harness, a test runner, which is putting your system through its paces for whole use cases. So it's calling out for use cases. And you could put as part of system testing kind of end-to-end testing from here. So the phone up to the server side. Protractor, ladies and gentlemen. Was one system that you folks used for that. What's the level of above that? In some industries, it's really rigorous. In some industries, it's very well defined, very formalized, and it's a handoff step to the client. If it passes these tests, it's ready for the client, and the client will accept it and will give payment at that time. Hundreds of thousands of dollars depend on the outcome of this test. What's that sort of test called?
A/B testing.
Sorry?
A/B testing. Alpha and beta.
Alpha and beta, we'll get to that. So those are good, but often those are undertaken partly for marketing's sake, partly to get the user community able to test it out, but they're not yet a formal gating process in the sense that the customer then has to buy it. The customer often buys it after that, and with beta testing, it's often used as like the last right? They develop these release candidates, and then finally after release candidate 7 or 8 or whatever, they release it. But people don't have to buy it. I'm talking about particularly custom software built for organizations. What's the type of testing that's that far end? It's called acceptance test. Yeah. Yeah. Okay. Acceptance tests, ladies. Those are different levels of testing. And you can map them to kind of what levels of the system or types of criteria do they test. We talked about test. Oh, we'll get to that. Path-based testing, ladies and gentlemen. We have several lectures on testing. Using different levels of path coverage. Give me a couple levels of path coverage. A couple levels of kind of coverage that we might try to achieve. State coverage. How about another? Transition. How about a level that subsumes that? That is, it's if you achieve this other level, you've automatically done transition and state. Prime path coverage, yeah. What's a level that you could talk about, but it's impossible to get in almost all systems?
Is that the one that's super exhaustive?
Yeah, exhaustive, all possible paths. All possible paths are covered. Ladies and gentlemen, suppose you had an oracle that could let you perform all possible paths of testing on this small code base. You have some embedded code, and you could perform all possible paths of testing. Could there be defects in your system still?
Yeah.
Why?
Because defects can come from the data that goes through it.
Yeah, the data could be very different. I mean, just because you've gone in this loop in a certain way and you've checked that this branch is taken, different branches are taken, that doesn't mean that it's going to handle all for different user inputs all correctly. So these, it's not that these are truly exhaustive in the sense that they're perfect for testing. But look, ladies and gentlemen, if you don't have statement coverage of your system, it's hard to say with a straight face that you have really thoroughly tested your system, because there's some parts the code has never even gone to. Now, realistically, on real systems, often we can't. The fact is, we don't actually get even complete statement coverage with our test suite. So what do we do for those parts that aren't covered? What do we do? What other ways are there to gain confidence that the code is correct? What other ways besides testing?
Inspections.
Yeah, peer reviews. Peer reviews, right? You can do really good peer reviews. In fact, some of the best ways peer reviews, look, there are some things that are really good for testing, where testing can really wail on it. Tested in all sorts of sort of race conditions, all sorts of sort of funky timing and timeouts. And there's other things where it actually plays to the strength of our reasoning concerning error conditions and, this is impossible that you'll reach this place and so on. We can actually often reason about it, and especially very rare conditions. It may be hard to reproduce it in terms of testing, but we can reason through it. So path-based testing, we talked about prime paths, and that would be an example thing. I could ask you to derive prime paths for some little algorithm or statement level or path level. Path-based testing, this isn't perfect, but no testing is perfect in realistic systems of any size. It's not going to be perfect. It's a matter of do you have credible reasons for confidence about it. And, this helps build your confidence that it's working. We talked about testing for object-oriented systems in one lecture. What's different about testing for object-oriented systems? What might be different there?
Encapsulation.
You can't reach into an object and look inside it to see all its internals, because it has lots of private data. So what might you put into that object that would help?
Test hooks.
Test hooks. Think testability, ladies and gentlemen. How can you improve the testability of your system? Test hooks are a great example. What's another way you can improve testability of a system? Logging. Another way. Assertion use. Another way. Specifications. Another way. Scripting languages that can sort of drive it internally. These are all good ways to improve testability of a system. Testing for object-oriented systems, what else do you have to worry about? The 470 people in this room should be able to shine here. Okay? Violation of Liskov Substitution principle. Suppose that one class, you have two classes, A, subclasses B, and A has promises that are consistent with those of B. It can be passed around like a B, and it has promises that are consistent, so doesn't give anyone any surprises. That's the Liskov substitution principle. It's about the promises made. Are the promises of the subtype compatible with those of the supertype? If you think you have an instance of the supertype and you actually secretly have this instance of the subtype, can you be rudely surprised? Because it doesn't adhere, it adheres to different promises than the supertype. It adheres to promises that are inconsistent, which could rudely surprise you. Like the subtype is mutable where the supertype is immutable, and you're counting on it being immutable, but the subtype can be changed. That's about Liskov substitution principle. But what else can go wrong in an object-oriented system when you have A being a subclass of B?
Unsafe subtyping.
Okay, unsafe subtyping is one thing, and then another thing would be broken subclasses. Could a subclass be broken even though the subtype makes promises that are consistent with those of supertype? Is it possible that the subtype over time, the subclass that supposedly implements that type could be broken? Yeah, the superclass evolves. Remember add and add all, ladies and gentlemen? No, you folks won't remember it, but the 470 folks will. Hopefully with some pleasure. The evolution of the superclass can break a subclass, and vice versa, without even the Liskov substitution principle. So there's issues, ladies and gentlemen, that come in here with special issues with object-oriented systems. Another reason why, I said it for the 470, but I'll say it again here, that whenever I feel, like give these sessions, I have this bittersweet feel, because I feel I'm, like, if you come here, you're gonna all ace the exam or something. And then I mark them, and then I feel bittersweet again. Because I'm relieved that I didn't make it too easy, but then some people didn't suit so well. Ladies and gentlemen, what's the thing that's limited with my ability to do mocking in object-oriented systems? Mocking was actually introduced. The idea of mocking really came to the fore with object-oriented systems. But why is it limited in the context of subclassing? Because you can't mock a what? A superclass. Can't mock out a superclass. Ladies and gentlemen, if you have a superclass, and I'll use different letters. I don't know what this is. It's a really interesting. I feel I'm erasing something pretty important. Okay, ladies and gentlemen, if you have you have a class C and D is a subclass of C, D's implementation is entangled with that of C. Why do I say this? So this is a subclass relationship. Why do I say it's entangled? It's implement. Note my words. And unfortunately, in 470 final, I didn't italicize the words. There was one question where I was asking about implementation, and I didn't italicize that like I should have to sort of attract students' attention to it. But if D is a subclass of C, not just a subtype, not just, C is an interface and I'm saying D adheres to it, but it's actually a subclass. I extend C. D extends C. So it's a subclass relationship. Why do I say that its implementation is entangled with that of C? Because often C has in it several methods. Foo, bar. What other method might it have in it? Baz and zap. Yeah. I mean, imagine it without those. And suppose D, it can override foo, right? Or, maybe we'll say just without lots of generality, foo calls bar and baz, which both call zap, right? Maybe D overrides bar and it overrides zap. And suppose now I think I have a C, but it's secretly a D. Someone gave me, so I have some method called foobar. No, it's called process, okay? And it's pass process. And oh my God, sorry. Oh my gosh, I can't spell. Well, that's okay. I'm past. I like to be marked on that. Okay, so it gets what thinks is a C, and somebody calls it with a D, right? Someone calls it somewhere else in the code. Calls it with a new D, right? And it gets what it thinks is a C. Secretly, it's in this case a D, right? It's a D being passed to it here, right? And it calls off to foo here. Whose foo is called? The foo of who? Foo's, yeah. C's, yeah. I know. Some of you are wondering, I'm going to say who you're going to call. And we've been through that. You're probably sick of my jokes. They go in kind of modulo fashion. One of my fellow faculty members, he had a sort of retirement together with a 70th anniversary celebration, and he went up. He's a wonderful, wonderful chap. You folks, unfortunately, have never probably met. And he said when he got married, I think someone told him, maybe it was his wife, his to-be wife, maybe it was someone else, said, one way, in order to keep your wife, for life, in order to have a good, strong marriage, what you need to do is tell a new joke every day. And he said at first he was, really shocked. You have to learn a joke every day. And then he realized, wait, human memories only go so long. And so all you need to do is remember something like a year's worth of jokes. And then you can do modulo and just, roll. Okay, it's January 23rd, time for the joke about, instead of better late than never, it's better Nate than Lever, or something like that, and you roll it out. And January 24th, it's time for who you're gonna call, Ghostbusters. Okay, so ladies and gentlemen, when you call foo on C, who you're gonna call? You're gonna call this one in C, right? Now, when I call that and foo calls bar, whose bar is it gonna call? Whose bar is it gonna call on this? So foo, and I call foo on this, and internally The foo that I call is going to call bar. Whose bar is going to be called?
C's?
Well, it's been passed something, so it looks like a C, but in this case, if it's passed it, something that's actually a D, it's in fact going to be calling off to D's bar, right? And then, you notice this overrode bar in Baz. Okay, now bar calls zap. Whose zap is going to be called? Well, did this one override zap? No, so it's calling C's zap, right? This is why I say they're entwined. The implementation of these two are entwined. This guy's calling that guy, this guy's calling that guy. Do you see what I mean? They're tangled, ladies and gentlemen. They're tangled up due to overriding. Now, we talk in 470 about some of the implications with that add and add all, and the implications for subclassing interfaces, and how to make sure that the two stay in sync, and specifying what needs to be overridden together and what needs to be, you need to specify what needs to be, what calls what. But that's 470, that's not 371. You folks are not responsible for that, those who didn't take 470. Okay. But, ladies and gentlemen, you should know that subclassing brings entangling of classes. You're entangled with your superclass. Now, normally when we're testing, how do we deal with tangling? If you have interdependencies between A and B, you want to test a class A at a unit level and it calls B. What do you do with B? You mock it. But can we mock out C here? Can we mock out the superclass? No, we can't. We can't mock it out. And that's why I mean that we're limited in terms of testing object-oriented systems, in terms of what we can do with mocking. There's this extra barrier, ladies and gentlemen. Those are some of the ways in which testing with object-oriented systems is more tricky. And in general, if you're testing D, an object of type D, do you only test methods bar and Baz to see if they work properly? What else might you test?
Superclass operation.
Yeah, you need to test all the superclass operations because you've inherited them and you have entangled yourself with them. You've overridden some things, and you might, ladies and gentlemen, you might have broken them. Can you believe that? Could D break the functionality of C? You bet it can. You bet it can. And so you've got to test all these operations in the superclass. And sometimes this ain't the only superclass. It goes up and up from there. So you've got to do a lot of testing associated with that for object-oriented systems. Special needs, ladies and gentlemen. Test case design, orthogonal arrays, boundary value testing, picking out those values between different categories, testing at least one thing from each category, equivalence class testing. You want to test at least one coach seat, at least one aisle seat and window seat, or what have you. You're testing a square root operation. You want to test 0. You want to test 1. You want to test positive squares. You want to test positive non-squares. You want to do a test of a negative value. Remember, when you're testing, you want to test things that lead to failures too. This is one of the big problems with having developers test their own code only. I'm all for developers testing their code. Start there. Unit tests are typically done by developers. But then you have to have someone else test it. Maybe it's buddy testing, where A tests B's code and B tests A's code. That was in your mess. I think I removed that question from the exam, but I might be wrong. It was there, but I had to cut it down because I didn't want it to be death by 1,000 cuts. Right? So I learned from the 470 exam. That was a bit long. One student wrote an unkind comment saying this was the longest exam they'd ever written in their entire life. They were about 2/3 of the way through. So I listen. Okay, so ladies and gentlemen, but buddy testing is a way to get, because people, when we have other people test their code, they're less sympathetic, therefore they may find things that we miss. You may find things that we miss in our testing. We're testing to make sure it works properly, to feel we did a good job, and they'll be testing clever cases that might break it. That was, of course, what the black team was famous for at IBM. They would cackle and sort of, frog their fingers and then break your code. And sometimes it led to adverse emotions, because they would sometimes take apparent delight in crushing it, which is not kind, but it showed the power of being able to sort of know how to test things really well. Tips for testing. We actually talked about a lot of basic sort of tips for getting started in testing, something about the relationships between testers and developers. Test associated with sort of, resetting test cases afterwards, after they're complete. Logging test results. Ladies and gentlemen, when you run a test, you need to make sure the results are saved away, and generally you need to reset the state of the system. Because a test may, again, it overwrites a file that was there, right? Or it puts something new in the file, or it updates something in the database, or it deletes a bunch of information in the database. Whatever it does, you want to be able to rerun it. Why would you want to be able to rerun that test reliably? Why would you want that? To rerun it easily. Yeah, you want to be able to rerun it in a reproducible way. So if it failed, you want to be able to reproduce that it failed. Yeah, very reliably. Every time you want it to be the same, right? You don't want it to be based on chance. Oh, that time it didn't fail. Oh, that time it didn't fail. Maybe I'll be lucky this time. You don't want it. You want it to be totally reproducible. Oh boy, ladies and gentlemen, I feel really bad sometimes. I wish we could have a class. I say we. Maybe no one will show up besides me. We could have a class in testing and debugging, or class purely in testing methodologies. In debugging too. I sit beside students sometimes. Students bring me all sorts of problems, and they're not only all about me. They bring me lots of problems with code and so on. And what you'll find is that there's certain methodologies you can take to debug, which make it really, really quick to debug. You can become very skilled at quickly zeroing in an error by being resourceful in a certain way. It's not brilliance, it's not luck, it's not just sort of happenstance, and it's not flailing, really quickly. It's actually having a methodology for doing it, developing hypotheses, testing them in systematic ways, being clever about how you try things, simplifying the situation, cutting away unnecessary complexity. You can just go for it. And there's a gap of about 10 times for how much you can speed up debugging with that. 10 times. And it pains me. It pains me that we don't have the opportunity to do that together. And one of the most fun things I like about my boot camps is, so I teach these boot camps worldwide, and people bring me problems, and sometimes they strike in the middle of lecture, and then they get to see me debug them. Or sometimes there'll be a problem on a user's computer, and I'll go fix it. We thought about having GoPro when so we go over. Fix it, and people can see, but maybe you'd rather watch it, wing sailing or something. Anyway, it's one of my regrets here. Maybe in another few years I'll ask the department head if I can add an extra course and do less research and just teach that, and finally I'll feel less bad about that. Testing procedures. We've talked a little bit in testability. Key things with testability: making your program able to be tested. Give me some examples of test hooks. Test hooks are one of those concepts that students often feel puzzled about. Give me some examples of test hooks.
Simulating a condition that you can't really predict.
Yeah.
Running out of memory.
Exactly. Running out of memory, running out of disk space, corrupt file, network timeout, slow connection, disconnection. I mean, maybe, you may think, well, I don't need to simulate no disconnection. I could just unplug the cable, right? But you don't want to have to do that every time manually. You'd like to be able to have an automated set of tests drive these things. So those are good things. What other thing might a test hook do? Yeah, access private variables. So maybe you have ladies and gentlemen, you might have a component, a class, which is one interface which is meant for people who are using the class in a normal way, but it also implements an interface meant for testing. So it implements certain methods, maybe with sort of limited access to this package or something. Only other things in this package can access them. And those are meant for testing the internal state. And what those might test are invariants of the class, for example, history properties of it, but invariants, things you could test at any one time. Does the dictionary have any null items with null values or null keys associated with it? Is the dictionary empty? Is this data structure, smaller than a certain size? Does it have any duplicate keys in it? There's all these things that often we end up assuming in our code to be true, and you can go through and you can test those things with these test hooks. Test hooks provide ways to kind of peer into things, to change the state in ways that you'll get to see the results, cause error conditions. They can be something that can significantly enhance testability, because then you can look to see if the data structures are being updated partway through an operation. You don't have to look just at the resulting values from the operation as a whole. You can look at what the data structures are along the way and check properties of them. So these are testing related. Scheduling. I need you to know about a couple things. Scheduling, ladies and gentlemen. Gantt charts. What do Gantt charts show? What's on the x-axis? Time. What's on the y-axis? Tasks. And each task is associated, it delineates some sort of period of time over which it's operating. And some Gantt charts get elaborated with dependencies, but that's really a later addition to them, reflecting the other type of method we talked about, which is CPM diagram. Traditionally, Gantt charts didn't encode dependencies. They kind of illustrated what the anticipated timing was for these different tasks, but not if this one slips, what does it mean for the others? And that's key information. The way we capture that is with a CPM diagram, which is a DAG. What do I mean by a DAG? Directed acyclic graph, right?
Is CPM critical path method?
Yeah, critical path method. Yeah. What is a critical path?
One where if any of the tasks are delayed, it delays the whole thing.
Yeah, you folks are good. That's great. Great. Really pleased with how this class has gone this semester with the projects, and really pleased to see people have such good memory here of these items. So it's a critical path method. You have a directed acyclic graph. Directed, meaning the arrows are, if we draw an arrow on edge, it's directed. It's from A to B or from B to A. It's not, undirected in a way it just connects the two. It's acyclic. There's no cycles. It doesn't go loop back on itself. And it's a graph. It has nodes. There's vertices and edges. And when you have a graph like that, ladies and gentlemen, here for tasks, these arrows, an arrow from A to B indicates B can't start until A is finished. Now there's a generalization of this that you'll find in Microsoft Project, Primavera Project Planner, and many other project tools, or a number of other project tools, which generalize this so you can not only have what are called finish start dependencies, you can't start B until you finish A, but also allow start to start, finish to finish, or start finish dependencies. And we didn't talk about that, you're not responsible for it. So CPM diagram, a CPM algorithm requires what things as inputs? What does it require as inputs?
Task duration?
Good. Okay, so first I'll list, and this is I think implicit in your comment area, task duration. Okay, but even before that are tasks, right? Really, I should be above this. An enumeration of the tasks, and for each one duration. So what else? Dependency. Basically a listing of where the arrows come from and go to. We okay with that? What does it give you out? So these are the inputs. These are the inputs. What does it give you out? Okay, for each node, for each task, nodes are tasks, right? So these tasks are these nodes, and the dependencies are these guys. And for each task, what does it give you? Early start, early finish, late start, late finish, right? What does it mean by early start?
The earliest the task could possibly start given the ones that come before it.
Beautiful. You're the man. Exactly right. That's exactly right. Several people in this class, you know, I like marking exams. I can check. It's really good. So that's great. I'm hoping it's everyone in this class. I'd love it. I could just go through. Early start, early finish. Ladies and gentlemen, what's early finish? The earliest you could finish this task given everything else that has to go in before it. What's late start? This is the tricky one. Well, the two lates are the tricky one. What's late start?
The latest it can start without delaying the entire project.
Beautiful. Beautiful. There's some ones I had real trouble grading on 470. Someone gave me so I asked, I think, what was the analogy I used repeatedly to illustrate the analogy I repeatedly appealed to illustrate the Liskov Substitution principle in non-computer terms? I think it may have been that question or the next one, and someone said it was an analogy about Yoda. I was trying to figure out how that came in, but I had to spend a while. It was almost written in a Yoda-like fashion, and I was trying to figure out what was meant, but right, I wasn't able to penetrate its meaning yet. I'll go back and look at it. Someone else had a nice cartoon driven with FedEx. It was great. They showed a little FedEx truck and it was driving. It's really impressive. Late start is the latest it could start without delaying the whole project. Late finish is the latest it could finish without delaying the whole project. Okay? And the CPM algorithm consists of two passes, a forwards pass and a backwards path. It's overall of order n. Each of those passes is of order n, where n is the number of nodes. What does the first pass determine?
Early start and finish.
Early start and early finish. What does the reverse pass determine? Late start and late finish. Early start and early finish. You can't start a task until the max of the finish times of all the tasks that have preceded it, right? You can't get in the cab until you've finished eating and finished packing, what have you. Finish eating and finish talking on the phone. The backwards pass computed late start and late finish, because you computed the latest time finish or start, the latest time it could finish, given the latest times things after it could finish. If even one of those things that can start after it, that will start after it, that depends on it, if even one of those that are waiting for this one to finish needs to start early, then this one needs to finish early to avoid delaying that project. You got that? So, you know, if there's several things, like here, if D is dependent, you know, it's not until D finishes that C and E can go forward. They both of them to go forward. The latest D can finish without delaying the project is the minimum of the start times of C and E. Right? Because the minimum of the late start times. Because the late start of C is the latest it can start without delaying the whole project. It's gotta start by that time. The latest E can start is the latest it can start without delaying the whole project. And if you want to avoid delaying the whole project, D then has got to finish in time for those to start in the requisite time. And so it's got to finish by the minimum of the times of the late start of those two. Does that make sense? Again, we use this reasoning in our head a lot. We don't realize it, but that's what it's calculating the backwards. So the front, you sort of calculate early start from the things that preceded it, and from that you get early finish for it by just adding the duration in this simple case. In this case of where we have only finish start dependencies. And you go forward from that. Backwards pass, you're figuring out the late finish based on the late starts of the things that are after it, the minimum of them, and then you figure out the late finish for this node by just subtracting the duration. Okay? Ladies and gentlemen, what's the critical path? How do you figure out the critical path?
One where there's no float.
Yeah, there's no float. What's the float of a node? How do you figure out the float or the slack?
Early finish minus late finish.
Good. Early finish minus late finish, or late start minus early start. They're going to be the same. That's going to be the float for a node. What does that float mean? It's the slack, ladies and gentlemen. It's how much that node can be delayed without delaying the whole project from when the earliest it could possibly go to the latest. You know, the earliest it could possibly start to the latest it could possibly start without delaying the whole project. What's the give there? Maybe it has 2 days of leeway because you're waiting for another task that takes even longer. So you actually have a little bit of time with this one. You don't have to order this thing as early because this other thing takes much longer to get here. Okay? So that's scheduling critical path method. Gantt charts don't traditionally encode dependencies. System state and project dynamics. I actually asked you to watch a video on that. Some of you have taken 394, will have seen it more. Basically, the things in the video are testable, including building causal loop diagrams. And I've included in the final pages of this document, you know, some examples of causal loop diagramming applied to projects, illustrated in different ways. Generally, we'll have nodes that represent variables of concern. They have some polarity. You can have more of it or less of it, and if you really, if you don't have that polarity, the sense when you have more, when you have less, you need to refine your concept more before you put it into the diagram. So developer fatigue, we could talk about more fatigue or less fatigue, and we could talk about more morale or less morale. And the focus here is not on things that are directly observable always, so though sometimes they may be, but sort of what's driving what. So the idea here is if you have a link between one variable and another, say between backlog of work and developer fatigue, if there's a plus arrow, if there's an arrow from A to B, and there's a plus associated with it, if you increase A, it will tend to increase B compared to the value it otherwise would have had, all other things equal. Now that's a weirdly complex way you may think of saying it, but it actually heads off some misunderstandings, okay? One thing is, there may be several things affecting this other variable, so it doesn't guarantee that it goes up just as you've increased this compared to the value it otherwise would have had if other variables are changing it as well. So you want to say all of the things being equal. Nothing else is changing. How would it change that? The second thing is just because A increases doesn't mean that B increases, so it's increasing over time. What it means is that it increases compared to the value it otherwise would have had if you hadn't changed it. A increases, and we compare the value of developer fatigue that would have obtained with the original value of A versus the one that obtains now that we changed the backlog of work. How would they be different? Is it bigger or smaller? So here, backlog of work goes up, all other things being equal, developer fatigue goes up, people are working longer hours, I really should put that as an intermediate variable. As developer fatigue goes up, morale tends to go down. That's a negative arrow, and that means if you got an arrow from A to B with a negative polarity, if A goes up, all of the things being equal, B will go down. Down. If A goes down, B will go up compared to the value it otherwise would have had all those things being equal. Okay? So in this case, there's a negative one. So as developer fatigue goes up, morale will tend to decline. And as morale tends to decline, there'll be ripple through effects. There's another link here to resignation. So as morale goes up, it's a negative link. If morale went up, resignations would go down. If morale goes down, resignations will go up. So as backlog of work goes up, developer fatigue goes up, that tends to lower morale, leads to more resignations. And more resignations leads to lower morale, further driving morale lower and further leading to resignations. This is called a what? A begins with an F. Feedback loop. Yeah. It's a feedback loop. It can be a reinforcing feedback, like the squeal in a microphone. If you put a microphone close to a speaker, if you heard that before, it gets louder and louder and louder until it maxes out the speaker or what have you. It can be a positive, so that's a reinforcing or positive feedback loop. Positive not in a sense it's good, positive in the sense that a small change tends to be build on itself. It's amplified over time. It's reinforcing itself. It grows itself. It leads to a ripple set of changes that ripple around and adds to itself. By contrast, the negative feedback loop will be one that's self-balancing. So, you know, I'm hungry, and you know, I go and I get something to eat, and that lowers my hunger. That's a regulatory loop. It's a loop that brings the system back into balance. Same thing with our temperature. Same thing with thirst, etc. Right? Salt balance. Our system, our bodies are full of these systems, as are our organization. Negative feedback loop leads to balancing behavior. A positive feedback loop leads to unstable behavior, divergent behavior, behavior that can change very quickly. Not all of that behavior is bad. Companies want reinforcing feedback loops to grow their market. They want their products to go viral. So, you know, you sell a new app, you want people to talk about it, so they want their friends want to buy the app, and it just grows and grows and grows and snowballs. And soon, Casper is on everyone's phone, something like that, right? And that's an example of a virtuous cycle, but it's reinforcing feedback. By contrast, there's some vicious cycles that are also reinforcing feedback, where things get worse, and one of them is shown here. Adverse morale leads to more resignations, which leads to worsened morale and yet more resignations. And those are the sort of things that can lead a project to go to hell in a handbasket in a quick time. It fall apart. It goes non-linear in a sense that you get very rapid deterioration. So, closed loop diagrams, you should spend some time to learn how to put them together. Now, the fascinating thing about these is that if you come to understand them, even without building, so these can be the basis for a simulation model, which is a great way to go. But even without doing that, you can learn to recognize patterns that, for example, quality factors, when it comes to software development, are at the heart of driving a lot of the, of sort of limiting or driving a lot of the outcomes for morale in terms of resignation, customer happiness, customer sort of satisfaction, which further leads to sort of morale impacts. That's not even on here. And how managers react to, say, being behind, project lateness, is a big factor. Ladies and gentlemen, many managers in this world, many managers and many others, they mistake symptoms for cause. They react to symptoms and they try to deal with the symptoms themselves without dealing with the underlying causes. Give me an example of that. I spoke about it in that video you hopefully watched. But does anyone remember an example? Confusing symptoms and cause here. Okay. Projects behind. We're way behind schedule. Project manager is feeling the heat from the customer. Customer is pretty unhappy. They want progress, they want it soon. Project manager says they want people all working at least 4 hours of overtime a day for the next few months. I would say in some cases that may be disastrous. Why?
Fatigue.
Sorry?
Fatigue.
Yeah, you gotta understand okay, why are we behind schedule? Is it because people are on vacation? Is it because we've got real quality problems? Is it because our developers are so overburdened already and fatigued that they're just churning and not getting quality? Is it we've got just one developer, at the brunt of things, and that's the real bottleneck? We got to understand why. I mean, if we end up dealing with the symptom, we say, okay, we want to double the hours for people, have them work extra overtime, and people are already fatigued. That could be like a death sentence, because people will quit, people will leave, people will, their morale will go down, or will worsen the underlying situation. If we find the issues are the project's behind because it's there's miscoordination between people. Another common managerial thing, and it's often a trick, mind you, to save their butt, is add people to the project. You say, look, I'm going to save your project. I'm going to do whatever it takes to save your project. Here's your project's 20 people. Here's another 20 people to work on it. They'll start tomorrow. Okay? 20 new folks. You can't fail now, can you? And you'll be delivering in 2 months' time. I'm going to give you all these resources. Now it's up to you to pull it off. And then, if your project size, you still couldn't pull it off. But really, they gave the kiss of death to your project because it's already having coordination problems, and they add another 20 people. It's going to make it worse. Dealing with the symptom, ladies and gentlemen, symptom of being behind, people often react in the wrong way, and they end up focusing on that and saying we need to have people work longer hours in ways that are inimical. Another example, manager here's there's a lot of bugs that have been found, poor quality, a lot of problems coming out of peer reviews that have been found that point to poor code quality. So the manager says, okay, we're going to penalize people if your code gets identified as having defects found in a peer review. You're going to be docked for pay, or we're going to cut down. You're going to wipe out the chance of a bonus, or it'll count against any chance of a bonus. What do you think is going to happen there? They're going to go improve the quality of the code base? No. What's going to happen? Yeah, people are going to hide their bugs. They're going to blame someone else for it. It was his bug. It was him. He told me to do it, or they'll, the peer reviews will be like a kangaroo court. They actually won't even write down what was found. They'll just whisper it to each other, and the project manager doesn't know. And the project manager gets increasingly disconnected from reality. Increasingly disconnected from what's going on, because now the information being propagated back to them is not accurate about the bugs and so on, and it just becomes adverse. Things like that do occur. There have been companies where that sort of thing has happened, and people have tried to link up code quality to pay, and it just leads to gaming the system, and it leads to sort of hiding of information, etc. Or project manager gets really upset. Thinks, okay, I've got to scare these developers so they really understand. No more smirking at me. I'm going to go in there and scare their daylights out of them. And that also leads to really adverse effects. It leads to just suspicion of the manager, hiding information, worsens the problem, worsens the communication, often it puts it further behind. Ladies and gentlemen, managers can be very, very good and attuned, got their ear to the ground, listen to the real causes behind things, and others react to the symptoms. And the fact is that quality issues of code quality, end up having this ramifying effect. They end up sort of affecting all sorts of things throughout the system in this tangled series of linkages. And one of the most important isn't even on here, which is customer satisfaction, which leads you to be able to hire new people, etc. So causal loop diagrams help illustrate the sort of the complexity of this system that interlinks these factors, and they can help us understand about how these disparate components, morale, fatigue, aspects of testing, thoroughness, quality of products, delay of a project, resignations, how those sort of fit together, and they can help us identify these vicious cycles we've got to identify. Now, one of the most important points that I want you to get you clued into here is the following. Because managers will sometimes focus on the symptoms, they end up making the system a lot in worse shape. And I've worked on projects before where a manager said it's behind, so we will cancel vacations, or you've got to notify me 3 months ahead if you're going to take more than a day off at a time. No one can take more than 2 days of vacation for the next 6 months. They end up restricting the time outside for activities that lower people's fatigue. And what this ends up doing is it ends up breaking the cycles that stabilize the system. So when we have these systems, there are these positive feedbacks, reinforcing feedbacks that lead the system to spiral out of control, lead to resignations and low morale and poor code quality, time spent hiring, and just a project that's churning, it's not getting any traction. And then there's balancing loops that have to do with keeping the system in balance, so the system can recover, it can stay in balance. And what managers will often do is they try to cut these loops because they consider them wasteful. They consider them as sort of unnecessary frills during the crunch times. And what that leads to is a worsening of the situation. The system spirals more out of control. And as best I can tell, your projects escape that. But not all former projects in this class were so lucky. And we saw a number of these vicious cycles talked about by students and manifested in adverse product deliveries. So this issue of balancing feedbacks, keep the system stable, kind of a homeostatic regulatory regime where it's stable and able to survive, the project coheres, versus these things that are trying to pull it towards a divergent situation, an unstable sort of situation. Those things are in tension, and what you don't want to do is under the crunch time cut these things that end up stabilizing it. You want to have some time away to stabilize, and it's very important that managers not cut those for long periods of time. Short sprints are one matter. Doing so for many, many weeks or months ends up being a real problem. And in our lives, we have to make sure these balancing components are in place, or else we'll often find out, we may end up not properly sort of being able to self-regulate. So this is some aspects of sort of systems thinking. Oh my gosh, wow, isn't that really interesting? Okay, here we go. Systems thinking, project dynamic. Human capital and software. Ladies and gentlemen, this was one lecture. I talked about this as a component of a lecture, I think. I don't think it was a full lecture. The idea here is, look, from the perspective of bean counters, sometimes people are focused on the costs of things. People cost money. People are money drains. Software developers are money drains from that perspective. And we got to economize by paying them less. There's a countervailing argument, to which I'm very sympathetic, that look, people are not just numbers that are interchangeable. It's not just you have a number of people who are soak up so much dollars. They're, from a company's perspective, they're also investments. They're things that learn over time, that deliver value in accordance with that learning, where morale is very, very important, and so on. And this notion of people as sort of a cost that needs to be minimized versus an investment that needs to be sort of made in a sensible and judicious fashion is a tension you will see. And in the technology domain, within the past decade or longer, there's been a real recognition that when it comes to software, we need to invest in our employees. There are exceptions to this, but a lot of companies, Microsoft, Netflix, Google, Yahoo, etc., in some cases, they're famous for how they invest in their people, in their organizations. Sometimes it's investments like training opportunities, go off and gain skills, which you then bring back. Sometimes it's investments in terms of morale. You allow these people to pursue their own project one day a week of their choosing. One day a week they can work for a charity, they can do this neat little project that they've been hoping to do on the side. They can take time off for vacation on a long basis. I think I mentioned Netflix has unlimited vacation policy the last time I saw it. If you want to take a year vacation, you can do so. The point is that investing in people often pays back in a big way, because if you lose a really good person, you cannot replace them by just hiring another. Often you lose equivalents of hundreds of thousands of dollars of lost productivity because you bring someone on. When you are working to bring them on, what is going on? So those hundreds of thousands of dollars, those are not all due to one cause. Give me one reason that bringing a new person on is expensive. What happens? Start training. And it's training by the most valuable people on the team. It takes them away from other duties, often from development. What's another thing that goes on?
You could lose the knowledge.
You lose the knowledge. They've walked out, and so there's going to have to be a long time gaining that knowledge again, especially in certain specialized areas. There's a certain knowledge in the room on strengths and perhaps even some weaknesses with Oculus Rift and Unity. And you know, if I were to say, okay, I'm going to have that team go forward, I'm going to get 10 really good students, assemble them, and take that project forward who have never worked with Unity or Oculus Rift, how productive do you think they'd be in the next month? Dream on, right? Yeah, it would be pretty grim. And actually, the lack of productivity would last for months and months and months. Maybe reinventing the wheel, or worse yet, they'd reinvent the flat tire, right? Right? Or the square wheel. Ladies and gentlemen, coming back, gaining the knowledge again is a big thing. What's another thing that goes on when you're going to try to hire someone? You interview them, and often you go through many candidates to get the right person. You get the person who sticks. Maybe you interview 10 people. That's a lot of time out of the time of developers. And it's not exactly great morale to see some really good candidates not come. So, you know, there's lots of morale there. While you haven't yet hired that person, who's doing the work? Often the people who are still there. Do you think that adds to their morale? Suddenly your workload is doubled because your buddy in the next cubicle over, you've got to do their work? No, that doesn't raise morale. So there's big losses when people leave. A lot of other people think about leaving. They hear about the great job this person got at a firm across town or something like that, and they wonder for themselves. So this issue of human capital, I mean, people are precious resources in software development. And you know, there's a school of thought out there that, and I'm actually rather sympathetic to this, that except in the most extreme cases, if you hire someone and you try to get, and you work them with your team, they might not be the perfect match, as it turns out, for the position for which you hired them. But they have some strengths, and they're probably pretty good at certain things, and you find a place for them to really shine with those things. If you're a large enough firm, you have the opportunity to do this, and you sort of fit them, so maybe they don't fit into the desired piece of the puzzle, but they can work elsewhere within the puzzle to fill in a key set of needs. And you know, you invest in that person and build them up rather than losing them, because the cost, even though they're not a great fit right now for the project, the cost of losing them is just too great. So this human capital in software is a dominant feature of the software industry, with certain exceptions. And one of them, I'm sorry to say, is the game industry, where there is, in commercial games, there are some pretty cutthroat type of things that go on in terms of managing the people in the game companies. Certain game companies treat them like commodities because there's so many people that want to work there. They have such a market to hire people that they let people go and can replace them very quickly. They're not often concerned, and they don't pay them that well either. But by and large, good software companies really invest in their people. And if you're not getting that from a firm, you should really think twice. Is this a place I want to stay at? Because our field, ladies and gentlemen, depends on ongoing learning. And if you are stuck in a position where you don't have that opportunity to get further training, you don't have that opportunity to come up to speed on new technologies, to learn it in new areas, you are going to be not quite digging your own grave, but you're going to be putting yourself further and further behind the industry. And if you are in a position, by contrast, that invests in you, you can stay current in a way that no matter what happens to the firm you're in, you'll have opportunities. You'll be able to go elsewhere. So you want that company that invests in you, that can recognize that and that can let you rise within it as well as take up other opportunities. Human capital. Teams and team dynamics. A fundamental issue here is, ladies and gentlemen, the unit of analysis within software development these days is generally not the person. People are very, very important, but the unit of analysis that makes a product reach its potential is often the team working together. And I introduced a notion called a gelled team, which is a team which has achieved a level of trust and self-determination and sort of comfortable familiarity and joint knowledge that they can be incredibly effective in sort of working forward and sharing knowledge and not losing that knowledge. And within the agile project dynamics area, this is really a real thing sought. So there's this, I don't know if you folks have seen it explicitly. I mean, had I more time, I probably would have given a lecture or two on agile development. But this was actually mentioned by our last guest lecturer. The Agile Manifesto. It's an interesting document. It's now some time back, but basically it was a reflection of a revolt against traditional top-down waterfall model, Big Bang type software development, with a focus on processes, rigid processes, heavy documentation, and very rigid control over when a customer could request extra changes. And it basically envisioned a new type of software development called Agile. And that goes by various names: extreme programming, Scrum, Kanban. There's a whole series of Crystal, there's a whole series of different variations of it. And the Agile Manifesto sort of laid out the thinking behind this. And basically, instead of keeping the customer at arm's length and saying only once you have to submit a change request through this long change process and so on, it said, look, we're going to deliver something. We're going to have something in front of you every 3 weeks or something like that, every 2 weeks. We'll rush in this, we'll show you something, and then you say what you want to do next. We'll get it in front of you. We'll get it to you on an ongoing basis. We will do it in small little bits instead of a whole chunk for 6 months and then have a big bang where it doesn't quite come together for another 3. And we will do so in a way that values the members of our teams, values morale of those members, keeps the documentation low, keeps morale high by investing in people so that we don't lose people a lot, and so the team is gelled, it's coherent, it sticks together for a long time, people can keep a lot in their heads, and they can be incredibly productive because they're high morale, and they invest in their code quality because they feel good about what they're doing instead of it's just a job that they do 9 to 5 and leave and don't really take ownership of. So there's this idea of sort of Agile Manifesto changing the notion of software development so that it was much more human-centric. And if you go look at it, it's a quite thoughtful, if somewhat impassioned document. And I checked that out as it relates to team dynamics. Okay. Estimation. We gave a couple principles for estimation. A couple observations. Observation 1. People tend to be poor estimators. And they tend to be poor estimators in a way that puts themselves at disadvantage. They tend to underestimate how long things will take. More than that, as your interaction with questions regarding blue whales and books published in 1776 and currency in circulation and the surface temperature of the sun suggests, we are also tend to underestimate our uncertainty about things. We tend to be too narrow. We tend to be not only overconfident in the sense that we estimate it will take less time than it actually will, we tend to overestimate how closely, how sure we can be of our answer. We tend to say, our answer is probably within pretty tight range, and actually it's a lot more variable than that. And we tend to do so in a way that's really bad, because if we underestimate how long it will take, we're setting expectations that almost certainly, if we're off, would almost certainly lead to more disappointment than if we had overestimated. If we said it would take 6 months to deliver this, and it actually takes a year, we could have a pretty unhappy customer. Because they're betting getting out in time for Christmas season, or they're betting, to transfer their operations over to the new system by late this year, and they are pretty upset that this has all gotten screwed up by the delay. If you have just overestimated, you estimated 6 months and it actually takes 4, often they're pretty darn happy with that. So we're off in ways that put us at disadvantage. And so what do we do about this? Couple things. One thing is, don't give point estimates if at all possible. Give range estimates. Why range estimates? Why range estimates? They communicate uncertainty. They tell person, are you very uncertain, or are you very confident about how long this will take? That's really useful information. Secondly, they're less likely to be taken as promises, as commitments. Often we as software developers think in terms of targets. We'd like to try to do it in this time. And we give a target rather than an actual honest estimate of how long is it really likely to take. Ladies and gentlemen, range estimates are a great step forward, but they also, besides those virtues, they force us to think through what are our uncertainties. What's the worst that could happen? What's the best? They force us to confront thinking about what could go wrong, and that's really useful. Now, when we create these range estimates, we are advised to use a process called decomposition, which is a process used by some of the firms here in town. Basically, you take a big chunk of work and you think through what are the particular sub-steps of that work. We can fool ourselves really easily thinking about just a chunk of work as a whole. But if we break it up into pieces, we can reason about how long each of those pieces will take, and we can come up with a more informed estimate for the whole. And we can think about how long this piece might take in the worst case or the best case, and come up with an informed estimate for the whole. What I'm not going to ask you to do, ladies and gentlemen, I'm not asking you to go through that whole thing with statistical estimation as part of the final exam, okay? I can promise you that won't be on the final exam. But those points I've just made, general points about what you got to watch out for, the basic processes we go through, the fact that you can't just take the worst and best case estimates for each piece and add them up to get best and worst case for the whole thing. There's some statistical sort of adjustments that are needed. I don't need you to know the exact details of that, but I need you to know that these are the case, and it really helps to think through the pieces. Okay. Now, what's another way we avoid being so far off in our estimates that the folks who put together the Agile Manifesto might have have reasoned through that they might have known intuitively when they put that forward. Well, again, we can fool ourselves when we think about big chunks of work. But if we're thinking about a 1 week sprint, we're thinking about a 3 week sprint. We gotta get this thing in the customer's hands in 3 weeks or in 1 week. We're thinking in very concrete terms about how much we can do, what exactly we need to do, often what we need to do on Monday, Tuesday, like this week, what are we gonna do? And we have to be very concrete about what resources are available. So, so-and-so, Joe's at his sister's wedding, he's out of town. This other person's on vacation now. This other person's out ill. I've got this load of other things to do to answer this customer bug in an earlier version of it. We're thinking in very, very concrete terms about this week, and we have less ways of fooling ourselves that way. We're less likely to be off by a big amount, a big, big amount. And if we are, it's okay, we want to get that extra feature in and we couldn't, right? We want to get 3D volume visualization in and we couldn't. We time box it, so we just couldn't do it in time. But it's not like it's 6 months behind by the time I see it. The customer is enraged, right? So by breaking things up into small pieces, a week at a time, 3 weeks at a time, you're unlikely to get the customer, shockedly despondent about your progress, because you're giving them something there, and it sort of brings them back into what you can do in that period of time, and you get wiser about how long it takes for each, and you ask them, what's the next step? Because often what gets the customers upset, if they only knew earlier that something was going wrong, they could have done something. They could have requested a smaller set of features. So you give it to them in pieces, and if it's taking longer than they anticipate, they adapt their requests accordingly. Ladies and gentlemen, agile. Agile. I won't jump around in a simian type fashion about that one, but I personally am quite supportive of the ideas. Okay. Quality coding. We talked about this a little bit, particularly in the area of specifications. I was very pleased in the 470 exam, for those who took it, to see the responses about the, like the last question and bad smells in code. Some of you took that exam. Maybe you weren't pleased with it. I was pleased with the answers. One person, I think they had a number 11 or something, burn the page or something like that. Burn the computer that this code is on. There were various creative solutions to it. But the point is, repeated code is ugly. Code that's written with inscrutable variable names is ugly. Very long functions, ugly, confusing, inviting errors. Code that has lots of nested structure. It's not abstracted into separate functions. It's ugly. The same conditions again and again is ugly. Unnecessarily can cause bugs. Seeing constants in there, 50 here, 100 there, 10 here. You don't know if they're related. 99 here, 101 here, 999, 1001. Are these related? Are they somehow linked? What's the relationship of one to the other? It's not clear. And quality coding is about those factors. It's about recognizing those repeated chunks and abstracting them into a reusable unit that we can call in many places and so on. I'm not going to be hitting this nearly as hard in the exam, nor did I in class for this class. I actually thought you folks did actually a really good job on the projects. I'm actually very happy with where we're at. Very happy, and I think the code bases are pretty good, pretty darn good, given where you come from and given all the other teams that have worked. So pretty pleased with this. There's not going to be a big emphasis on this in the exam. Okay? But I want you to know it matters. I want you to know it's tangled up. You don't have quality coding. When it comes to these loops, when it comes to sort of these components here in red, you got a lot more debugging to do. You got a lot more failures that are discovered that need to be tracked down for faults. You're spending a lot more cycles fixing things. And you have customers that aren't as happy because bugs get through. There's a lot more time for rewrites, and it really drives project success. Let me ask this, ladies and gentlemen. If you found a bug, sort of moderate level of severity with the bug, and you've got to ship your system to the customer, you've got to provide it to them for deployment within the next 2 days. Are you always going to fix that bug? Why not? Sorry?
It might cause more.
Might cause more bugs. And critically, and this is a key thing, it might cause more bugs that you don't have time to find, advance, and fix, right? I mean, this pipeline is a pipeline for a reason. Things don't instantly go all on here and get fixed, get queued up to get fixed. It takes time. And in those 2 days, if you're lucky, you might have time to see some of those bugs, but you don't have time to go and sanitize them and go and prioritize them and try to fix them. Basically, at some point, you run out of testing cycles. You don't have time to if you fix this, you don't have time to discover are there more bugs and through testing and fix them. You run out of that time. And that's a very real consideration for projects, that at some point you say, it's easier to put out a workaround. It's easier to warn the customer or leave the feature out. You don't have it there, or say this feature is not yet fully operational. Set expectations or exclude it rather than trying to put in a last minute thing. Because at some point, game's up. You don't have time to test it properly. You don't have time to debug it. So you leave the sleeping dog lobby. You stay with that bug you know. Because you can put in the warnings, you can notify the customer ahead of time. It won't be quite working in terms of this, it'll work under these circumstances, etc. Quality coding. Ladies and gentlemen, if you don't get the quality right, things fall apart. Morale goes down. People don't like putting out lousy code. Let me put it this way, more than that. Good developers don't like living with lousy code. I've worked with some of the top developers in the world, and I kid you not. And those people put out exquisite code because they feel a sense of craftsmanship and their thinking is clear about it. It's gorgeous. Pick up the book Quality Code if you want to see some quality code. It's good stuff. And people don't like working on a code base of crap. Sorry to say it. It's just people have a sense of self-dignity, and you want to feel good about your work. You want to feel you're working with quality. You're putting out good products, and you're not going to be able to keep really good people. You're not going to be able to attract them often, keep them, retain them. Quality coding is good to keep good human resources. It's good for the customer being happy. It's good for morale. It helps head off a lot of debugging effort, helps head off a lot of testing, helps put your efforts into, seizing early market opportunities, handling other risks. Quality coding is really important. Good quality software engineering. Putting in place that extra effort to sort of make it effective. It doesn't mean never making an expedient compromise, but quickly fixing it up through refactoring if needed. This matters. It has big implications. Requirement solicitation. We talked about this. Requirements, ladies and gentlemen. Eliciting an understanding of what's needed. With Agile, this gets done over time. But you start often with trying to get some understanding. And people are speaking a different language, perhaps. they're using terminology you're not familiar with or what have you, and it takes some time to zero in on the precise meanings of the terms. There's derived requirement. What's a derived requirement?
One that isn't specified by the stakeholder.
It's not a user requirement. It's not something they directly specify, but it's implied by what they specify. I've seen this in a number of projects, and with junior folks, they often don't realize this. They say, well, the user didn't request that. Yes, but this was implied by what the user requested in light of technical needs that go with it. The user doesn't know all the technologies involved, and they may say something, and to you, you know the technologies, and you understand, oh, that implies this, this, and this. You know, oh, so you need this system to trigger these questionnaires on a certain context based on this data. Okay, then it has to be done on the phone side. It can't be done on the server side. It has to be done on the phone to trigger it. And that has certain implications for how it's done, etc. There's certain implications, technically, the user's never going to pick up. But there are things the user is going to say, and you want to disambiguate them. So often you ask them to repeat a question, for example, right? You repeat back to them what you think they said. Or you ask them to repeat it again and see how they say it. Or you ask different representatives of the customer of the same thing and see if they hear a common thing back. Maybe you have more than one person listening, going along to talk with the customer. That's another good strategy, so that to make sure you're hearing common things. And you state them back in a structured way. You know, the system shall do this in this way with this qualification. I'm not going to be emphasizing this really heavily, but it's a very important component, because if we get the requirements wrong, then we may end up putting a lot of effort in that gets thrown out. Fortunately, with Agile, we're doing this on an ongoing basis. So with Agile, there's a limitation to how much we lose. Okay, we've done the sprint in a somewhat different direction, but at least we haven't gone 6 months before the customer sees what we're working on, which is how it often used to be. Continuous integration, I talked about that under QA, so I'm going to leave that out. Talked about entrepreneurship. I had 2 lectures on this, and you know, basically there's a lot to go on, but you should know a lot of basic features of the situation. Talked about a lot of issues with partners, heading off partner problems, putting in place structured documents for understanding, getting investments, issues with market segments. Ladies and gentlemen, a shrink wrap market, sort of packaged larger scale software is quite different from offering services as software. So downloadable software you install as a desktop app. It's a very different market than services you have online, where people pay per hour on the service. It's very different from mobile applications that people are keeping on their phone and that just sort of interact with resources on the web. And it's quite different from custom software development, where some company pays you to develop a product just for them as a consultant. And that in itself is quite different from a semi-custom model, where you're going around to different customers. You own the code base and you modify it a little bit. You deliver what to them delivers the value of a full product, but you actually keep the ownership of the code base. That's semi-custom. It's quite different sort of types of models and different pricing associated with them. We talked about startups often go under. They often go under for issues with first customer, partner problems, issues of not dealing with risk. You give out equity to partners, ladies and gentlemen, not just based on the contribution they've made, but the risk that they are bearing. If you have two partners, one of them, both have contributed thus far equally to the software. One of them has quit their job to work on this. The other is holding a job. You better reward the person who's quit their job more, because they have skin in the game in a very serious way. Whereas the person who's holding a job, they're insulated from risk in a way that's not directly comparable, and they need to give up some equity. Ladies and gentlemen, early in a company's life, you often don't have the option of paying money, so you pay equity. Investors expect equity. An angel investor, a venture capitalist firm. What are they looking for? They're looking for equity and sometimes for venture capitalists control. They want to put their managers in place, put their marketers in place, what have you. They want the equity though is the key thing, and they'll often give you money in return for that equity. Sometimes they want equity dominance. They want to be able to call the shots. Sometimes they take a small bet and have a high leverage. They give you money for that. Legal documents, you got to watch out for. I talked about incubators. Incubators are great little things. There's some in town, including in various forms, co-working spaces, and more formal incubators. These are places they offer a bunch of services. Often, at the least, it's co-working space. So you're working in a common area. You can have multiple firms kind of sharing the space, so it's a lot lower cost. You might have one receptionist for everyone. The receptionist can take messages. You might share a boardroom, so you can meet with customers in an appropriately formal place. They can feel comfortable about it, but it's a shared boardroom that you have to book. They might have shared resources in terms of IT, of networks. They might also have legal services available, marketing advice, marketing and promotion advice, people who can advise on the taxes and financial side. Incubators are great little institutions, and they can help a company survive that critical first phase. Entrepreneurship is something that in software is readily possible because of low capital costs. It's not like founding a biotech firm where you have to buy giant tanks and major equipment that costs hundreds of thousands of dollars together with the labs. You're dealing with low costs associated typically with humans and some services to sort of keep them connected, etc. Often it's quite nice sort of risk profile, and it can be a wonderful experience. You got to be very careful though to watch the formal agreements and to watch the expectations, and cautious about going into it with best friends. We also talked about negotiations, principles in negotiation. Ladies and gentlemen, do you always hide information during negotiations? You want to always hide information from the other? Certain types of information, yes. What do you want to hide from the other person?
The reservation price.
Reservation price. Your BAT now. What's the BAT now?
That's an alternative to the negotiated agreement.
This is great. This is great. Yeah, best alternative to the negotiated agreement. Okay, you have some offer from Noodle Cake, and you're negotiating with Zoo. You don't want to tell Noodle Cake, or you don't want to tell Zoo what Noodle Cake offered you. That's often quite linked to your reservation price. Though you may be shooting for more than that. But there are some things you want to tell Zoo about. What do you want to share? Your preferences, ladies. You want to share information about your preferences. If you care a lot about working from home, you want to communicate that. If you care a lot about salary, you care a lot about the starting date because you want to take that trip to Europe you've always wanted to do. You need to communicate these things because they may be able to work with you to put together a package that has that right mix of the things you care about, you nail, and the other things you give up a little bit. That are things maybe that are more important to them. So getting a sense of what the preferences are of each party is really important. Another key thing is putting forward packages, multiple packages. I'd be happy with this, be happy with that, happy with this other thing. Maybe one of them say, okay, this one we can talk around. These others, they don't speak to us. This one, that's worth talking about. Let's sort of iterate on that. And that's often how negotiations go. Put your preferences out there, you sort of circle and kind of get a sense of what you're after and sort of your attitudes. They're going to want you to tell you their reservation price. They're going to say, so tell me, what would it take to get you here? What would it take to get you here? And you want to be quite cautious about just saying one thing about one thing, salary alone or something. You can put forward multiple packages, and then maybe they'll go with one if they anchor on that, and then you start sort of tweaking around that and come up with something that might work for both parties. Very hard to do this. Ladies and gentlemen, if you can coordinate negotiations to go on at the same time, if you're talking with multiple firms, it's really hard to make decisions in serial. You have to end one before you can begin the other. That's really hard. You can't compare them against each other because you don't know what's going to be coming on down the road. If you can somehow line them up so time-wise you could choose between a couple at a time, much more efficient. If you have them only one at a time, it's a much harder thing because you don't know what still lies ahead. You don't know what you're giving up by accepting now, right? Or by giving this up, you don't know if something better is going to be coming. So we talked about negotiations, just some general principles there that are important. I'm really looking for you to know. Well, I may have given away the show. Some overarching. So that was slide one. Should we go on to the slide? Okay, so I went through. Basically, that was like stream of consciousness, some of the most important things in the course. An awful lot of the important things in the exam are in what I just uttered. An awful lot, more than I'd like to admit. Okay, overarching things, proactive thinking, action to lower vulnerabilities. Ladies and gentlemen, we live in a dangerous and uncertain world, but there's a lot we can do to proactively to shield ourselves from these things in the world. Yes, it's true that a lot of bad things go on out there, but there's a lot we can do to make ourselves less vulnerable to these things. That's what risk management is about. That's what a lot of software development is about. It's not, it's like you don't leave if you have a cottage up north, you don't leave your door open all the time for animals to wander in. Make themselves at home. You don't, when you go, you pack it up for the winter, you don't leave the door open, because you come back, you find a porcupine chewing on the spruce or something in the house. Or you find a moose on the loose. This is not this is not something you do. You wanna watch out to lower the vulnerabilities. Just like you don't leave your door open, you don't leave your door open for bugs. You put in place properly structured, well thought through contracts and code and so on, tests to protect yourself. We just got to be mature as developers, and the same thing with protecting ourselves from risks. So risk management proactively. Recognizing that uncertainty and risk are not always bad, we can embrace them if we can manage them properly. There's weaknesses at the interfaces. The interfaces between people. It's the interfaces between areas of code, between methods and so on. Are they, is this observing the preconditions of that? I wish I could tell you something, because I keep on seeing the same mistake again and again. In an understanding on the preconditions, postconditions. I wish I could stop, but I don't want to take everyone's time with that. Postconditions only have to obtain if preconditions are met. It's only if the preconditions are met that the postconditions are guaranteed. You can broaden preconditions, say I accept a larger set, and then do things to the postconditions for those things that are quite well specified. That's actually okay. For those in 470, that may mean something. For others, you don't have to worry about that. Opportunity costs, ladies and gentlemen. We have limited resources. Choosing one thing means not choosing others. Advantages of doing things early, getting them out of the way, getting the requirements in place, getting user feedback, etc. Quality, ladies and gentlemen, quality is at the central part. If we invest in quality, we can actually help all sides of the iron triangle. What's the iron triangle, ladies and gentlemen? What are the nodes on the iron triangle? What are the vertices?
Time, money, and quality.
Good. Yeah. Time, dollars, and here you'll find different people using different things. Quality or scope of it. If you invest in quality, it actually helps all three things. It can shorten time. Don't spend as much time debugging, rewriting code, etc. Lessen the cost because we could do it in less time and people time, and it improves often the quality of the product, the sort of functionality of the product, etc. Quality, ladies and gentlemen, is one of these things that pays back. You'll sometimes hear in the TQM space, the total quality management space, the idea of quality is free, and there's a certain sense that that's true, that it pays for itself. There's another sense in which, yeah, it's not true, but in a certain sense it is true. Within certain bounds, you could say that that's true. And here in contrast to 470, we're really talking about the hard and soft things. Ladies and gentlemen, when we build systems, the users are part of those systems. We have to build it considering the fact that users who are confused will sometimes make mistakes. We need to build systems that are robust to those mistakes, that anticipate them, that head them off. People's behaviors are part of the system. We have to anticipate people's motivations on a project, for a software development project, but also for the users of systems. The role of incentives within projects, making sure that people are incentivized, for example, to fix bugs before going on to new development. Talked about indirect effects of pressure, long hours, and so on, and some sides of negotiation and human capital. Software development there's a human theater to software development that this class talks about, and that you experienced on your teams much more so than we get into in 470. Software development has these critical human factors. It's humans that produce software and humans to coordinate effectively, to work together effectively to produce, on time, on budget, with appropriate scope. They need to accommodate the fact that it's a human system, and to reward people accordingly, and to work with processes that will accommodate the limitations of people. So those are some overarching sort of themes of the course. I talked about various best practices, risk management, scanning. What's risk scanning? What does it mean to scan for risks? What are we looking for there? Sorry? yeah, but we're looking for more than just any old risks. We're looking for two issues. Mark my words. We're looking for risks that we had identified materializing, coming about, risks that we had feared. Secondly, but new types of risks that are coming about. So it's an ongoing source of monitoring. You don't just do it once and say, okay, we've enumerated a risk. You're always looking, okay, are they coming about? And are new ones coming in that we didn't anticipate? I would say your teams, some of the teams here really experienced new risks partway through the project. Risks you didn't anticipate. Things that came up that broadsided you weren't aware of. In some cases, it was relationships with the client, the stakeholder. In other cases, it may have been technology things you just didn't expect, like the fact that with Unity, there doesn't seem to be an effective way to test or to mock. Yeah, these are things that you don't anticipate, and you want to identify those new risks. Accountable positions. Imagine if you didn't know who the project manager in your team was. You didn't have a project manager. Things wouldn't have gone so great. Peer reviews. I heard a lot of comments about good results of peer reviews and so on. Incremental delivery in these small pieces. I think offered a lot of value here, getting things in front of the client, getting things delivered for your sake, so you could see the full delivery. Mini milestones are things checked off. Is this done? That's good stuff. Continuous integration, smoke testing, and regular testing, whether by hand or in an automated way. Status updates on build fail, fail builds, brief meetings, scrums out here, meetings outside of that. Designing for testability, defect estimation, risk-driven testing, test creation before coding, or testing at different levels. Version control. Imagine doing your things without Git or Subversion. Imagine sending code files in the mail to each other. Would have been disastrous. It's horrible. Horrible. Version control makes a difference. You learned a lot about how to do it, I think, in your teams for larger teams, how to tag releases, etc. These are important components in professional software development. Test-driven development, some of you really applied some of that. In any case, developing these specifications, which allowed people who didn't develop the code to at least more quickly understand what's done there. Time estimation, we saw some big variances between what was estimated and what actually took place. Process improvement. Ladies and gentlemen, you find a bug. You find a bug in your code. You don't have time to eliminate it because the final deliverable is due too soon. Or this next deliverable is due too soon. Let's suppose you never fix the bug. Can you still benefit from it? Why? How could you benefit?
You can bridge back to what caused the bug and
Yeah,
evolve your process.
exactly. What has caused this bug to come about? Or what has allowed this bug to go unnoticed till then? Why did it slip through our processes? What caused, was there miscommunication between different developers, misunderstanding of the technology? Was it a change in the underlying technology, incorporation of a new library or something? Was this bug something that came about because of a misunderstanding of the requirements of one of the members of our team? You can put in place process improvement. How can we do things better? That's really profound. Compared to just fixing the bug, which is a comparatively minor thing, we can head off a lot of similar bugs in the future. That, ladies and gentlemen, is real bugs, even if that bug never gets fixed. You debug your process. And this is not about adhering to some perfect abstract process. It's finding really what works with your team for your type of deliverables, for your type of product. And, I made sure that when it came to these teams in the class, that you had quite a bit of latitude. So one team in terrible trouble testing with Unity and so on, with Oculus Rift. Sure, invest in manual testing, semi-automated if possible, but pressing buttons will trigger some test runs or something like that. Pressing buttons on the UI. Be intelligent when adapting things. We're dealing with this cacophony of different technologies. Try to be intelligent about adapting these processes to them. You heard about it from some of our guest speakers. You go in with this idea of agile, and then you adapt it to your organization in this way. It's a better adaptation. There's no shame in doing that. The shame is not learning from the mistakes. You should be able to learn from mistakes quickly so you can do better next time. And having those honest conversations about how can we do things better next time. Keeping that forward focus. Change control, how do you sort of reflect the fact, okay, we've got to change this, what are we going to do? I didn't really emphasize that this year, and these days with Agile, it tends to be not quite as important. The idea of spike or throwaway prototypes. We build prototypes to throw away. I have a whole swack of slides here that I'm certainly not going to go over, but which list some of the key principles for a bunch of different topics here, okay? Let me ask this. Alpha and beta testing. There was a question about it before. What are some advantages of what's the difference in alpha testing and beta testing?
It can be good marketing for users, actually.
Yeah, these are, in many ways, these are marketing mechanisms. Alpha is earlier stage than beta. Often with alpha, the expectations of the product are a lot less. Might not even be feature complete in any serious way, but you're doing some basic testing of it. It may change quite a bit. Beta, it's much more defined, but you set the expectations on the part of the user that they'll find bugs, there will be bugs, etc. But if it's too bad, what happens? You scare the users off, and they don't want to come back. Also, the test reports you get from beta testing are often of pretty limited quality, because people don't, they're playing around with it. They're not being paid to be a developer, a tester, and so the reports that they give of bugs are often pretty limited, if they report at all. They may just uninstall it. I don't want any part of this. I'm not using this. Come back later, and if you're really unlikely, they're gonna get scared off, say this thing is buggy, so I'll get out, and not come back. Maybe it does damage, overwrites the site. Alpha and beta testing though can be great marketing mechanisms. Kind of lets people see what's coming. Maybe it upstages the competition, lets them see, oh, we've got something really good coming along the way. It gets the excitement going for the final release, and it gets feedback from people and for power users on broad usage. Often it's the power users who are using this, and sometimes you open it up to industry partners, people who have bought a lot of your products, so get them using it and get their feedback on the system, etc. So you get people using it. Sometimes people start to use it in a way that if it's good quality, they'll transfer over to the full project. Okay. What's an orthogonal array?
You test all pairs rather than all combinations.
You test all pairs of values. So you might have 3 different inputs. Look, a crude way of testing would be, okay, for each input, you test each possible value of that input. And so there's some test case where you have, for input 1, you have value A, some test case where you have value B, for some test case where you have value C. And at least there's one test case with X and Y and Z, and alpha, beta, gamma for test input 2. But that's really crude because you're not getting pairwise testing. Often there's bugs that come up not because you've got A and input 1, but you've got A and input 1 and X and input 2. So with orthogonal arrays, you have pairs. All possible pairs between 1 and 2 are tested. All possible pairs between 2 and 3, between 1 and 3 are tested. But it's far, far less than all possible combinations of all possible values. So all values of 1 crossed with all values of 2, all crossed with all values of 3. That's often too many to test. So you test these pairwise ones. Okay? That's orthogonal arrays. A key idea there.
What's a Latin square?
Yeah, Latin square is a situation where you have, and I've got to get this right. I'm going to screw this up. It's actually, so we talk about Latin squares and Latin cubes and Latin hypercubes, okay? And the idea is very similar to orthogonal arrays in the sense that you have, so we consider a square alone if we're going to a cube here. We might have variable A here and variable B. And we are testing possible values. So maybe B has 4 possible values and A has 4 possible values, okay? And we are testing the possible values of A at least once the value 1 will appear. Okay, I've got to be careful for this. Okay, so we want each value of A to appear at least once in every test case, and each value of B to appear. So each value of A has to appear in at least one test case. Each value of B has to appear in at least one test case. Okay. And then if we have a Latin hypercube, we want each value of C to also appear in at least one test case. So there's at least one case where we have each possible value of B, each possible value of A, and each possible value of C. And similarly, we could have a hypercube, we have a fourth dimension of D. And you're guaranteed to at least have tested it once with the value of each value of that. And there we're not doing all pairs, but at least once we have that the value occur. Is that helpful? Yeah. Other questions about that?
Talk a little bit about test escapes.
Test escapes are things that you didn't catch in testing and they made it through to the production version and the user catches them. We didn't talk too much. Yeah. Glad you asked that question. These are things the user catches. Let me ask this. Okay, so those are the things the user testing. You want to ask, why didn't we catch that earlier? What allowed that to not be caught? What is it about our test? This is all about learning from mistakes, right? How can we do things better next time? How did this creep through? How did the bug get in there in the first place? But how did it creep through to this point? How can we improve our test suite so this is less likely to happen? Right? That's a very important question. And test escapes can be deadly because the customer sees them and you want to look very carefully at how did this get deployed? What do we have to do in our acceptance tests or other testing so these things won't happen again and similar bugs won't make it through? It's about learning maturely from things that go wrong. Not as a matter of shame, but as a matter of sort of what can we do better next time. Okay? And as I said, if there's shame, it's shame for not learning from the mistake. So ladies and gentlemen, but that brings up another question, which has to do with regression. What do I mean by a regression in software?
A bug that was fixed reappears.
Reappears. A bug that was fixed reappears is one thing. Sometimes you'll hear it used in a more general sense, a feature that used to work no longer works. Now, you may wonder, why is that such a big deal? Well, I mean, compared to any other bug, why are we concerned about regression? There's a big difference. Why? Well, ladies and gentlemen, particularly if the user is already using your system, let me ask what's worse. Suppose the user is already using your system and a feature that has been working has a bug suddenly reappeared that used to be fixed. Or it stops working for other reasons. How does that compare in terms of badness compared to a new feature not working when you first ship it to them? Which is worse? A new feature not working for them, or a feature that has been working for the past few versions suddenly stopping working? Which is worse? Sorry? The old feature is much worse that it stops. Why?
Betrays user expectations.
Yeah, it's user expect. I mean, they've been using this thing. They've come to rely on their processes on that feature. You know, they have word tables all throughout their documents, and suddenly tables don't work. That would be really bad. You've built your Google Docs around the ability to embed Greek characters, and suddenly Greek characters no longer are present. Okay, maybe that wouldn't shock you, but it would be bad for me. Maybe now images no longer appear properly. It'd be horrible. You know, suddenly all these documents that are broken, right? Because of this, if you've delivered negative value, you've taken away a feature which worked. And you say this is an upgrade, and suddenly, you know, suddenly the value disappeared. You sucked value out of their documents. That's really upsetting to a user, or it can be upsetting to a user. By contrast, if a new feature that they get isn't working, they'll just say, well, okay, no, so I can't use that new feature, that's disappointing. But you haven't sucked value away from them. Do you understand that? But another reason, just like Janelle said, that you're concerned is another type of regression is that an old bug reappears. Why is that different? Why is that of a special concern? Because it can happen very easily. Same reasoning was used as in the past, and it fails. Old code was merged in due to a merge conflict. You incorporated this old code, and that bug was still there. You roll back this source file because of some other bugs, and now you've got this old bug reappearing. It can happen really easily. And when it happens, it can be disastrous for the user because it can break a feature that was previously working. And this is why firms will sometimes run large series of thousands of regression tests, because they want to make sure that they're not delivering negative value. They're not taking away features that used to work and now no longer work. Does that make sense? Regression tests, ladies and gentlemen. Regression tests. Okay. What's directed triage?
Looking at bugs in the system and determining like how highest the priority in fixing.
Yeah. So directed triage. So triage is figuring out what we're going to fix and what we're not going to fix. You know, is this a priority? We're going to try to fix this for this release, for example, for this spring. Is this going to get done or not? And it's due to opportunity cost. We can't fix everything. We're going to figure out which of these things we're going to fix or not. I think all the teams had to do that at some level. Directed triage is about deliberately saying, look, we've got all these raw bug reports, or all these active bug reports. We're going to wade through them, particularly these raw ones, and figure out what are we really dealing with. Are we dealing with 10 reports of what's basically the same bug? Same underlying defect? Or we're dealing with 10 totally different things? Are some of these due to misunderstandings? Do they look like real, genuine articles? Are they things we've already fixed? Maybe people are reporting things that have already been fixed because they have an old version of their system. So directed triage is kind of wading through there, prioritizing, seeing what we're dealing with. Are these really minor things or are they serious things? Project manager might be involved with it, dev lead, testing lead, trying to figure out, okay, how bad is the situation? Are we pretty good off? Some of you even wrote that in your documents, right? Well, you've only one medium priority bug remaining or something like that. Great. Right, you went through, you assessed the situation, right? Good stuff. Risk-based testing, you test the areas you think are weak, soft, worrisome, new technologies, confusions in them. Ladies and gentlemen, separation of concerns, dividing things up into modules to well-defined functions. Why can that help testing? Abstractions. Why can it help divide it up into well-defined abstractions? Well-defined functions, for example, or methods, rather than all one hairball.
Makes it easier to pinpoint the source of a problem.
Yeah. Pinpoint the source of a problem. If you have well-defined code contracts, you can test each little bit of the functionality separately. The dependencies are made very clear what this depends on, and so you can easily set those and test it, and test the return value quite easily. So you can test the components of it easily. If it's one big hairball, it's hard to test except testing the whole hairball, and you don't know what's going on in the middle. Testing hairballs is not fun. So you divide up into these pieces, you document each piece, you have a specification, say what it takes as arguments, what it returns. It's cleaner to look at. You don't have to look at that code unless you need to. So it's lower cognitive load, but it's also a lot easier to test. you can mock it out or stub it out too. Stub those pieces out and put them in. There's this development methodology called tracer bullets, where basically you start with system as a whole, just things are stubbed out, and then you fill in more and more of the details. It's kind of an interesting take on things. So separation of concerns helps with testing. Another thing is you have those well-defined units. Then you have guidelines for what can be asserted, because you have these specifications. You can assert things at each place, and you have these key test points. Another thing you can do is you can more easily, for testability's sake, sort of interrupt what's going on and measure what's going on at different places within this through mocking or variants in it where you sort of trace the calls or what have you. Test reviews, ladies and gentlemen. Peer reviews for tests. I wouldn't worry about these things here. Oh boy. Ladies and gentlemen, three components of coverage procedures. Regardless of whether you're talking about node coverage, statement level coverage, transition coverage, on path coverage. What you want to do is you want to identify the set of things you need to cover. I want to cover the prime paths. You identify what they are. I want to cover statements. Identify what they are. I want to cover the transitions. Then you develop a series of paths through the whole system, from start to finish, to cover the things we need to cover. That will go through all the prime paths collectively, or that will go through all of the transitions. But these have to be paths from start to finish. The paths have to be paths from start to finish that will cover these things. And then you develop test cases, which are specific inputs that will exercise these paths. How are we going to get it to go this way or that way? You try to figure out, okay, if I give it this as an argument, think about that thing that you decoded URLs. If I give it this as an input, it will go this way. If I give it that one, it will go that way in the code. Those are sort of the components. We didn't talk about logic coverage, but basically there's a similar set of issues. Won't be paths. There will be other components, but that you can identify a set of things we need to cover, and there's going to be a set of inputs that will cover them. Critical path, longest zero float path. It has no float along it. No point does it have float along it within the diagram. No float along the entire path from start to finish. What's the longest such path? You know? If any of you are interested in human side of software development, Weinberg's books on quality software management, I have them all in my office, are really really thoughtful, as is Peopleware by DeMarco. These are some important topics on entrepreneurship. I talked about many of them. What's the difference in marketing and sales? We kind of hash them to the same bucket. What's the difference between them? Marketing helps people know about the product, get interested in it, be aware of it, be aware of some of its strengths, get interested in it. Sales actually closes the deal, actually achieving it. Ladies and gentlemen, I hash them to the same bucket in my mind. I think of, guys in suits walking around, put flashy, glossy things in front of me. But they're actually quite intention. When it comes to actually, like, if you're running a small software business, you want people to know about your product. There's something shameful about that. You want them to know about your product and have a good impression of it. Put the best foot forward for it. It's a good thing. Know about some of the trade-offs with it. That's good. Sales, though, when they actually come to close the deal, if you're dealing with a big client, they need that client to have reasonable expectations. Because if they make a sale and that client has overblown expectations, you're going to be in a world of trouble. Because this client's going to have expectations through the roof and you're not going to be able to deliver on. So often there's a tension here because marketing folks, and I don't approve of this in the least, but the fact is a lot of marketers out there, they're not technical folks, they don't understand the issues, and they oversell, they overhype things. Have you ever heard of architecture? It's like technical companies' architecture being presented by marketing folks, and it gets sort of turned into these glossy, vacuous things, and people describe it as architecture. You know, there's not a lot of substance to it. It sounds, it's great, but it's actually kind of shallow because you don't really know what's there, and really seriously what's substance in it. It's a lot of glossy hype sometimes, and there's elements of that. Marketing folks often want to make it just, it's great, it's just chocolatey goodness, it's just, you know, it's good, you're just gonna be so happy getting this, it's gonna meet all your needs, etc. And then the sales folks say, well, wait a minute, you know, this feature isn't fully implemented yet, you're not gonna have that in this version, and you know, this one's gonna cost a lot. There you have to actually get the customer to pay, and you want to limit their expectations so that they don't get a big letdown when they're actually working with a project. And unfortunately, the marketers often hype it up so much that the salespeople have to reel that in. Better marketing, you know, will keep expectations in line so that sales isn't so hard. But these are in tension often in a team because the sales folks are dealing with the more reality of the situation that, you know, you need a real qualified customer. And then the technical folks have to deliver on what the salespeople promised. And then if the salespeople are unrealistic, then the technical folks are on the hook. Because, you know, salespeople promise too much. And so the sales folks have to be more constrained in their kind of what they're promising. But they need the client to pay for it. So there's these tensions often between marketing and sales and those two and technical side.
Can we maybe ask you a question?
Sure.
Sorry. I thought you were. The post-mortem reporter, I think that's sort of the elephant in the room. Nobody really knows what to do about that.
Oh yeah. So I have great question. So I should have led off with this. You know, I stand corrected. Now I sit corrected. So, ladies and gentlemen, the exam has two areas on it that I haven't yet talked about. Two types of questions of which I have not yet spoken. The first of those questions, both those questions have significant import. So I will describe them now. The first asks you about your team. It asks you if you were given a bonus, how would you divide that bonus up amongst people in your team? Your answers are not shared with others. You are not able to reward yourself. This is a question for others in the team. How would you divide that up? Now, I'm only interested there in you could answer as if it were $1 million, so you can answer as if you were only have 1,000 or 100. But I'm interested in the relative amounts again, okay? The second question, also of import, is a postmortem. It's 2 pages long. I give you 2 pages. Now, if you want, you can use the back of those pages, but that's all I'd like. Now, if you want, that's a postmortem. It's a reflection on what went wrong, lessons. It's fundamentally a reflection on lessons learned, what we could do better, what went wrong, what lessons we can draw from it, how we can do better next time. And you could talk some about the team, although there's opportunities to talk about the team on that page where you divide up the money amongst them. You can comment on team members, contributions. Postmortem is sort of learning from it. I really read those carefully. I think I told you last year I had hundreds of pages to read. I read every one. So I think I owe it to the students to do that. And I get a very good picture of what goes on in this meeting. A very good picture. Now, you have the opportunity, if you would like to do it, of bringing in postmortem to the exam. If you want to, you can bring in a written postmortem and just hand that in with the exam with your name on it. In which case, you don't have to write that at the exam. But you also can write it as part of the exam, okay? And it's meant to be 2 pages, is what it's meant to be. I won't protest if you go to the 4, but because of realistic limitations to the size of the class, I don't want to be reading many hundreds of pages this year. So, and because I'm going to have the screws put on me to get exam marks, and as soon it's getting late in the month already. So, so please try to make it brief, but you're welcome to come in with up to 4 pages if you want to hand it for that. Yeah.
So if we bring it in,
Yeah.
do we have to label it in any way, or what's
You would
the
label it
procedure?
with your name and ID number.
Okay.
That's all. So it can be kept with the exam. And you'll be asked every exam page to give your ID number for that. So in case the exams come apart, I can put that. Postmortem, look, it's not a matter of length, it's a matter of thoughtfulness of reflection. Yeah.
Oh, just to clarify, for mark distribution, I think there's 15% allocated.
Hmm.
So then would that technically mean that the final is 45% if you combine both of them?
So, so it does matter. Those things do have import. I'm looking for thoughtfulness of that, and I'm looking for what we could have done differently, what we learned on this. I would include, however, Alan, here, in some of the remarks on your team, there's some very insightful remarks that sometimes people share in association with comments on team contributions and so on. For example, we've had teams where, there's been someone who hasn't contributed a lot technically, but they've been amazing in keeping team morale high in terms of organizing groups and, bringing things in for the groups and providing ways for the groups to sort of, socialize or what have you, and people will comment on those things, etc. They'll comment some on the team dynamics or what have you, and I consider those also, quite significant.
So these comments go into the postmortem or the ones beside the one?
That would normally be the previous one on the team contributions, but it could go into either one. The point is, I won't, in the 15%, I won't exclude it from consideration. I view both of them as sort of contributing to thoughtfulness of reflection on what went on and what didn't go on. Yeah. Okay? So, if you'd like to bring something in, you're welcome to do so. If you'd like to bring something in and write in the document, you're welcome to do so. How you'd like to handle that is up to you, but I will read it very, very carefully. Okay? The exam is shorter than 470 for sure. The exam is shorter than previous years, partly to give time for these things. Okay. Yeah. Other questions?
So I noticed that there are not a lot of slides posted on Moodle, so like negotiation
Oh,
and
tell me anything that's missing. That's good.
You put these final slides down here to see on there.
Really? I posted them. Huh, last night? No. Up in the slides area? Sure. Anyone else see them on there?
Most
No.
recently, soccer entrepreneurship.
Okay, so, I'd like you to check for a certain failure mode. Evaluate my failure modes, okay? This course, this year I also taught a course called 470.
I already checked, it's not there.
It's not there?
It's not there.
Okay, the plot thickens. Okay, so my second hypothesis is that it's due to a Moodle pathology, which I've seen before where things are hidden. However, I did check for that previously, which questions that hypothesis. But I will get that done before I get home. Okay? So right after this. Yes.
Last question. Could you talk about the differences between CI, smoke tests, and build?
Sure. Sure. Ladies and gentlemen, continuous integration is a regimen, it's a methodology, it's a protocol, it's a practice. Continuous integration, CI. The practice involves when things are committed, and typically it's quite frequently. Ladies and gentlemen, with continuous integration, mark my words, you are pulling people's changes typically once a day or so, daily at least. You're grabbing other people's contributions. You'll be checking things in, maybe less than that, although quite a few people seem to think you should check it in, within a day as well in terms of chunks of work. That's kind of part of the continuous integration ethos, sort of ethic of sort of doing that. But the real defining feature of continuous integration is when you commit to the code base, there is a build which takes place. Now when I say build, our mind as computer scientists probably gravitates towards compilation. It compiles, and that's surely part of it. But there's more to it than that. Style checks may occur. We may run Java docs to generate documentation, update online documentation from it. We may perform a suite of regression tests. At the least, we like to perform a smoke test. What is the job of the smoke test, ladies and gentlemen? The job of the smoke test is not to find new areas of bugs so much as to basically make sure that the system is in a sane state. When I say a sane state, I mean that it will not hose people if they go and pull from the system. That the system is of sufficient worth that is worth others getting, bringing over, pulling to their machines. If it's so broken you can't even log into it, or the basic features are crashing now, they might not be able to test their features. Again, you've delivered negative value with this build. You've taken away their ability to test certain areas of the system. You've broken core things. You do not want them to refresh their code base to get the latest changes. You want to roll back those changes until they are fixed. So the smoke test is basically a sanity check to figure out, is this latest check-in breaking the system? And if so, it should be rolled back. So it's a check on the sanity of the contribution, of the commit that has just occurred. And the key thing with continuous integration, the defining thing, is that when someone commits, it does this build. And the smoke test is a key part of ensuring, besides the compilation, smoke test jointly, if either fails, this build, this commit needs to be rolled back.
So is a unit test a part of the smoke test?
Sometimes.
Okay, it doesn't have to be, right?
Some projects will do unit testing, will run all the unit tests. In other projects, there are tens of thousands of unit tests, and you cannot afford to have them run on every build.
So if you're checking for sanity in the smoke test, why can't regression test be a part of the smoke test?
Because often you have tens of thousands of regression tests, and they may not be feasible to run, including many that run through the UI, and it may not be feasible to run them all. So, Chushina, the main issue here is we'd love for all the tests to run. The issue is it practical, given how long those tests take to run them all? Often we will run a subset of those tests that are a good subset, but we won't run all. So maybe we don't run the UI tests because they take too long. You know, they're literally simulating. I mean, many of you had this, right? You had UI tests, they would simulate clicking this Selenium, right? Do you want to run your Selenium test every build? Well, imagine if this class was not half a year, but half a decade in length. And you know, before you run screaming out of the room, imagine that, and you had built up tens of thousands of tests and hundreds and hundreds, if not thousands, of Selenium tests. There's no way you're going to run them every build. They just take too long. And so there you might run all non-UI tests during the build. It's just a pragmatic matter, because you don't want your builds to take so long that someone else is likely to check something in, you know, while it's still building, and only to find it's a broken build anyway, and they both have to roll back or something. You want the builds to be pretty snappy, so that you know, it won't take that long to do a build, and you'll be quickly notified if it breaks the build. How long did your folks' builds take when you were doing continuous integration? You did builds, I mean, was it taking minutes?
Tens of minutes.
10s of minutes? Yeah, see, that's long for a build, and part of that was probably tests that were running along with it. So, you know, realistically, we might tone down the number of tests so it will finish within 5 minutes or something. I think one of the teams had real problems. Was it the team with Unity? That there were real problems with, because you could only run one build every
Yeah, we had the cool
hour.
every hour, yeah.
Saying it ain't so. So I guess there it's, well, you still like the build to finish sooner so that you know about the problems earlier in the hour so you can fix it before the next hour.
It had weird benefits too, like you're less likely to check in a super build just because you can.
Yeah. Okay, so these are great things to say in a postmortem. Okay, you could call it retrospective if you don't prefer not to think of your project as dead. Okay, or you could think of it as an autopsy if your sort of view is opposite. But no, seriously, builds you generally want to be somewhat shorter. I'll tell you another reason why you want shorter builds is because often before checking in code, you want to run the build and the smoke test and sort of other things to make sure it's the same build on the developer side. And you certainly don't want the smoke test to take that long. And if there's a set of tests that could be run along with it to validate it, otherwise you'd like the user to be able to do that, and you don't want that build to take an incredibly long time. So it's all a pragmatic matter. A lot of these things are pragmatic things. Look, if it's too long, people are, you know, there's too big a risk that several check-ins will occur, etc. Okay, other questions?
Could you please
Yeah?
last time we needed it.
Yeah, oh, because of the misplaced staples?
Because of a massive number of papers.
Yeah, yeah, I could bring a stapler. Okay, you need a stapler gun? So, yeah, I'll bring a stapler. If it's any Schadenfreude, you know, you can rest assured I have to mark each page you go through. So, okay, other questions? Other questions? Going once? Going twice? Gone. Okay, nothing else right now? Okay, so I will go and, before I head home, I will post, negotiation, you said was not there?
Yeah, there were quite a few actually.
Is that right?
Yeah.
Okay, I'll go post, definitely the slides from tonight. Not sure what's going on there, but I'll post them and I will post, negotiation and the others may have to wait till I get home. Yeah. Good, anything else? Very good. Okay, oh, thank you. Thank you. Thanks. But I won't ask for the praise after the exam. No, you folks have done quite well this term. Pretty darn happy with that, and I'm confident if you attended this lecture, this thing you'll probably do pretty well.